Hello, everybody. Welcome back. Our next speaker is Dr. Brian Jordan. Dr. Jordan is an associate professor at the University of Georgia with a split appointment in the Department of Poultry Science and the PDRC, Poultry Diagnostic and Research Center. His focus is very much applied research for supporting poultry industry. Dr. Jordan has continued evaluating the spray application of IBV vaccines since his faculty appointment at the UGA in 2014. His lab has worked with many integrators in the US and Canada to monitor vaccine takers and troubleshoot application issues with hatcheries. Welcome, Dr. Jordan.
All right, hey everybody, thanks for having me. And so today we're going to talk about poultry vaccination management in terms of, precision poultry. And, to be completely honest, our technology advancement in vaccination has not moved forward very fast over the last 40 or so years, but we're starting to see some of that pick up. And so we're going to discuss a little bit of that today. But before we really start talking about the technology around vaccination, we need to understand and really remember why we vaccinate. All right, so we vaccinate, number one, to stimulate the immune system against specific pathogens so that when those birds are exposed to those pathogens later in life, their immune system can respond appropriately. It is primed and ready to go. We have a lot of misconception around when we vaccinate, the immune system is automatically ready to go. There are antibodies developed, or cellular system is activated, and that's not necessarily true. So it's really important when we vaccinate that we get all the birds inoculated so that all of the birds' immune systems are stimulated in the same way. And then for our long-lived birds, particularly layers and breeders, we're coming back and we're vaccinating continually to boost the immune system so that those circulating antibodies are there and those birds will be protected over the duration of their life cycle. And so there are three main types of commercial vaccines for poultry. And this is important to remember because these vaccine types, what type of vaccine you're giving is going to influence how you give it or what way you vaccinate. So we've got live vaccines, and our live vaccines may be attenuated or they may not be. So some of our attenuated vaccines are bronchitis virus, which I've done a lot of work with, Newcastle disease, some of our bursal disease vaccines, things like that. Some vaccines that are live and maybe not attenuated are most of our coccidia vaccines that we use in the US. They are just low, small, controlled doses and not attenuated in any way. We've got our killed vaccines, and there are a whole host of killed vaccines that we give as boosters to our layer and breeder sector for the most part. And then we've got our recombinant vaccines, and the recombinant vaccines are really where our big technological advancement in the realm of vaccines has come in the last 20 or so years, where we are taking a virus that gives you protection against Marek's disease and incorporating antigens from other diseases like Newcastle disease virus, bursal disease, laryngotracheitis virus, and incorporating those antigens into that recombinant backbone and utilizing those. But for these different vaccines, there are three main ways that we can administer them. All right, so we've got in novo. An in novo vaccination, you can see in the machine here, right? Imbrex is the most common and the most well-known in novo vaccination machine technology that's used. But that's where a needle injects the vaccine into the embryo somewhere around 18 or 19 days of incubation, depending on what your transfer time is. And it delivers vaccine directly into the amniotic fluid or even actually subcutaneously into the embryo itself. Very high tech, a lot of technology there, very advanced, very efficient way of applying vaccines, but not all vaccines can be applied that way. We've got our spray equipment. And if you look here, we've got our hatchery spray cabinets, and then we've got our spray equipment that can be used in the field, whether that is for boosting broilers with, say, bronchitis vaccine or applying your bronchitis Newcastle combo vaccines for layers and breeders later in life in the field. And then you've got injections, and that's subcutaneous, intramuscular, could be in the breast, could be in the thigh, could be sub-Q behind the neck. There's lots of different routes of injection site here. But we're not going to talk too much about injection because that's typically done by a standard crew. They're very practiced in that method, and there's not a lot that we're going to do to influence that particular route of administration. So let's go through each one of these a little bit in more detail and discuss some pitfalls, some things that you need to be concerned with or really pay attention to as you use these different administration routes. So in vivo vaccination, as I mentioned, it's very sophisticated technology for delivering vaccine directly to the embryo at transfer from the incubators to the hatcheries. This technology, it's been widely shown that you get anywhere from 98 to 100% accuracy on the injections. It's a really great way to apply, administer a lot of the vaccines that we have available. The machines themselves also have other technologies, right? So you've got heartbeat detection. You can remove dead or empty embryos. You have embryo counting where you can count the number of eggs moving through. So there's a lot of other things that are worked into this machinery. That's not just vaccine delivery, but vaccine delivery is the main function. We mostly use in vivo injection for recombinant vaccines. So those are our, like I said, our Merrick's HPV type vaccines. But there are some live vaccines that can be administered in vivo as well. For a time, there was a coccidia vaccine that was just prescribed for in vivo. Sometimes you can do some of your bursal disease vaccines in vivo, but mostly in the U.S. market, we use it for recombinant vaccination. Like I said, very efficient for delivery of vaccines that can't be mass applied or that don't necessarily need to be. And here's what I mean by that. A lot of our recombinant vaccines are registered for a day of age, day of hatch application, but the recombinant vaccines don't spread bird to bird. And a lot of our efficiency in hatchery spray vaccination, which we'll talk about in just a minute, is based on bird-to-bird transmission, the birds passing those vaccines back and forth. So if your application is flawed and not all the birds actually get the vaccine with a recombinant, they're not going to pass it back and forth. So that's why we try to give the recombinants in vivo. We really want to make sure that every one of those embryos gets that recombinant vaccine. But on the same note, sometimes maybe bronchitis is your biggest issue. And so you want to use some strong bronchitis vaccines because you're having a problem in the field. But you don't want to mix your Newcastle vaccine, a live Newcastle, with your live bronchitis vaccines because there are some cases where those don't play well together and you'll have a really exaggerated vaccine reaction. 7-day-old chicks, a lot of respiratory sounds, and that's not something you want. So you may move that Newcastle vaccination into one of your recombinant vaccines and do an HPT ND type vaccine, just to get that live vaccine out of your hatchery spray application so that you're focusing on what your major problem is in the field there in the hatchery with some vaccines that can't be used in vivo. One of those in particular is bronchitis. It's one of the major vaccines that we have not been able to develop a vaccine that can be used in vivo so far. So for in vivo vaccination, like I said, it's a very technical piece of equipment. The company that provides the vaccination machine is typically the one that does the routine maintenance. It's very high tech as far as moving parts and pieces, pneumatics, hoses, things like that. Really where the hatchery and where our workers come into play is cleaning. As you can see here, there is a cup that comes down over the egg. And I'm sure y'all are familiar with how in vivo vaccination works, but the cups come down over this egg, and then a punch punches the hole and a needle injects the vaccine. All of that's very straightforward, but getting these cups clean is very critical. And I've done some work in the past evaluating sanitation in whole hatcheries, but particularly looking at inside these cups, and it is highly variable day to day. But if this cup is not clean, if this cup is harboring bacteria, you're injecting a hole, knocking a hole in the egg here, and you're exposing that egg content directly to the bacteria that are inside this cup here. So that's a critical component. Ensuring that the sheaths and the needles are not bent. So that punch that comes through and punches the hole, and the needle that comes down and actually injects the vaccine. You want to make sure they're not broken, they're not bent, they're not clogged. There are vaccine trays you can use to test your vaccine dispensing every day. That's a routine practice at startup. Sometimes maybe the hole punch, the egg punch, or the needle, as you can see, this is the needle here in this picture. Maybe they don't depress every time. And then if they don't depress, they're not actually giving you vaccine. So just routine things that have to be checked with each one of the, on startup every day, usually once or twice throughout the day of using these machines. Now, we've moved past de novo, chicks have hatched, and we're looking at spray vaccination in the hatchery. This is where I've done the majority of my work, and we'll talk about some really precise things here. So spray vaccination is by far the most common method of mass application in the hatchery. And I'm taking in novo out of this comment a little bit because I don't really consider in novo mass application. It's just individual application on a massive scale. Spray vaccination is actually mass application where we're vaccinating populations of chicks at one time, not actually individually. Spray vaccination has been used for decades, and the technology has advanced incrementally a little bit, but we're basically still using the same type of spray cabinets that we used 30, maybe even longer, 40 years ago in our hatcheries. Now, spray vaccination is one of those areas that can be dramatically influenced by the hatchery personnel. And if you don't do it right, it can be very inefficient. And that's really where our work has revolved around. The majority of spray cabinets operate in the same basic way. You have a vaccine reservoir, you have syringes that pull vaccine out of the reservoir, and then they push vaccine out of the syringe out through these spray nozzles and onto the chicks that are moving through a conveyor belt. In the United States, we mostly only use fan nozzles and chicks move through the spray on the conveyor belt. In other countries, there are situations where the chicks are stationary and they're manually placed inside the spray cabinet. The spray comes out in a cone shape so that you get coverage of the spray cabinet or of the chick box, and then the chicks are manually taken out. But in the US, it's pretty well automated. And regardless of manufacturer, this machine is a traditional spray cox 2 by Merck. This is a DesVac machine from SIVA. They all work basically the same way. You've got your reservoir. You can't really see it well, but there's a piston here, which is actually just like a syringe, and it pushes the vaccine out through the nozzles, right? Functionally, they may look a little different. There may be some bells and whistles on some that aren't on others, but they all work basically the same way. The key with spray vaccination, doesn't really matter which vaccine you're applying. This holds true for Newcastle, for bronchitis, for coccidia, which are by far the 3 most common that are sprayed in the hatchery, but anything else that you may be giving to. Larger droplets are key. And I get asked all the time, what is a large droplet? How do I measure my droplets? How do I know if I'm getting large droplets? Those are all questions that I can't answer. There is no consensus on what a large droplet is. Traditionally, when we think of coarse spray, I would say that we probably think of something that's somewhere in that 300 micron range on droplet size. But if you look at the majority of the nozzles that we use in our hatcheries right now, the droplet sizes aren't that big. So it's really personal opinion on what you consider large and small or coarse and fine spray are. But what I can tell you that if you move up to a larger flow rate nozzle, then you by default are going to get a larger droplet than you previously had. All right, and that's where some of our most interesting work has come, looking at application volumes and larger nozzles to make that average droplet size bigger. When I first started about 10 years ago, it was 7 ml application in the hatchery. That's what we put everything through. We realized when doing this work that 7 mLs is just, it's not enough. So we tested 14, we tested 21. I think we've kind of come to a consensus on 14 that that's an acceptable amount of liquid to spray on the chicks. But that larger flow rate nozzle is critical when applying that larger volume to get you those larger droplets. And you want those bigger droplets for 2 reasons. Number one, bigger droplets are less influenced by air movement. Right, so if they're less influenced by air movement, that means more of those droplets are actually going to get down to the chicks, which is carrying your vaccine. And that's point number 2. The bigger droplets carry more of your vaccine, and there's less loss just by natural airflow, chick movement. Again, those chicks are moving on a conveyor belt through the spray. So the quicker we can get those droplets to them that carry the vaccine, the more effective our vaccination is going to be. Now, the biggest pinch point in the whole vaccination system with a spray cabinet, the traditional spray cabinets, are those syringes. All right, those syringes apply a lot of force and a lot of pressure to our vaccines. And we know without a doubt that those syringes can actually destroy the pathogens that are in our vaccine. They can destroy bronchitis virus. They can destroy coccidiosis. We've done that work and shown that. So you've got to ensure the pressure is appropriate on those syringes and that the stroke, the push and the pull are smooth. And I've got a couple examples of that. All right, so looking at some syringes on a spray cabinet, you can see how the vaccine is pushed out more slowly than it's refilled into the syringe, right? And we've learned that it's really that refill, that pull stroke, that causes the most shearing force, that puts the most differential fluid dynamic pressure on our vaccines. And that's what actually destroys the majority of our vaccine when it occurs. So that's what I mean when I say make sure that stroke is smooth. It should be a very even expel and then refill of vaccine in those syringes, not creating turbulence like this, if at all possible, not introducing air bubbles. Now, with a smaller volume, so this is 7 ml for each syringe to get to our 14 ml kind of standard in the US that I discussed. This in reality is not that bad, but when you go to other places that are applying larger volumes, let's say 25 ml, and we see something like this, right? It's one single syringe refilling 25 ml, and you can see how much force is being applied to that vaccine as the plunger pulls back and refills the barrel of that syringe. A lot of turbulence, a lot of shearing forces, a lot of air bubbles introduced, right? So you're not actually getting your full volume anyway, but that's really what we're trying to avoid. Now, the injecting vaccines, the injection system. There are some live and some killed vaccines that are used for injection, for IM or sub-Q injection. It can be done with chicks in the hatchery. It was done with chicks in the hatchery for a long time, or with growing birds in the field, as I mentioned, with our layers and our breeders. In the US, at least, the use of de novo vaccination has largely replaced injecting vaccines in the hatchery. We're able to move a lot of those vaccines into the de novo stage. And then with the development of the recombinant vaccines, we've been able to take care of some of the disease issues. So in the US, we don't see a lot of hatchery injectable vaccination, at least in our broiler sector. Sometimes in layers and breeders, you will for specific programs. But you do see it in other parts of the world and other places. Again, the injections most often done with layer and breeder pullets or birds in production to give you those kill vaccines for antibody titer boosting. We want to make sure two things: those birds have enough antibodies to respond to a pathogen if they get exposed in the future, and then making sure that, particularly in breeders, that they're passing on maternal antibodies to the progeny, to our broilers, so that our broilers are protected very early in life from some different diseases. The field injecting is usually done by a specific vaccine crew, and these crews have experience. That doesn't mean that they don't need to be checked on from time to time, though, because you are injecting a lot of birds at one time. A lot of these crews are based on the number of birds they can inject per hour or per day, and that may cause them to try to speed up and do more. But since you are injecting, you're putting a needle into the bird, you know, a lot of the same considerations as de novo. Cleanliness is really important. If needles are not changed, if tubing is not changed at appropriate intervals, if sanitary practices as much as can be done are not practiced, you'll see a lot of injection site infection, which leads to systemic infections. If those needles aren't kept sterile as much as possible. Vaccine handling is an interesting point here too. There's not a lot of room for really influencing our vaccines in ovo or in the hatchery. It can happen, but not to the same extent. But when we're handling vaccine in the field, how is that vaccine transported to the particular location where it was going to be used? Was it transported in a cooler and kept at the appropriate temperature, or was it just transported in the back of the truck? Same thing for the diluent or the water that's being used. Was that water treated? Did it come out of a well? Was it all in municipal water? Were there any adjuvants? Is there any stabilizer added? What's the temperature of that water when you mix vaccine? If it's a killed vaccine that's an oil emulsion or something like that, has the oil broken? Is the mixture correct on the vaccine vial before it is injected? All those things are really critical points that should be just common practice, but you do see mistakes happen with those. So that's sort of a recap of what our standard practice is, where we are right now in the industry. But let's talk about some technology that's coming on board and some things that we can use now and may be able to use in the future. Like I said, de novo vaccination is the newest technology, but it's been available for almost 30 years now. Spray vaccination equipment has been around for about the same time period, even longer in a lot of cases. Some of that's being updated. And then I know of a few things in the works with some vaccine companies on some different models and different pieces of equipment for injection, for IM and sub-Q injection. So I think they're putting some investment into that technology as well. One area in spray vaccination particularly is a constant pressure spray system. So in a lot of the work that Dr. Jack Wood here at the PDRC and myself did looking at spray vaccination, we realized, as I mentioned, that these syringes were really our pinch point, right? If we could eliminate those syringes in some way, that would take away a lot of the negative impact of the cabinet on our spray vaccinations. So we got together and designed what we call a constant pressure system. And this is just the prototype. This was the original prototype. It has actually been commercialized since this time and is being used in hatcheries around the United States with Merck Animal Health. But the vaccine, instead of being in a reservoir here and just drawn out of the reservoir with syringes, the vaccine is stored in a tank, and the tank is pressurized, and release of the vaccine is controlled by a solenoid. So when the chicks move through the vaccine cabinet, just like they would in a traditional system, the activator opens the solenoid, the vaccine is sprayed, and then when the chick basket leaves the cabinet, the activator closes the solenoid and stops the vaccine spray. But it keeps the pressure on the vaccine here constant. There's no differential pressure and no shearing force as the syringe is pushing and pulling the vaccine. And just to give you an example of why that makes a difference, in that work that we did evaluating spray cabinets, looking at different flow rate nozzles, different application volumes, and titrations of bronchitis vaccine, in our stock solution, our titer was anywhere from 5.5 to just over 6. But what we would collect in our chick basket, we would lose anywhere from 1 to almost 2 logs of vaccine. And the majority of that was in the syringes. Some of that was due to droplet size and droplets getting influenced by air movement, which I mentioned was important earlier. But most of this is due to the activity of the syringes. Now, when we look at the same nozzles, nozzle sizes, volumes in the constant pressure system, we can see we're only losing on average about 1/4 to 1/2 a log of titer. And that's mostly that portion that comes in with droplet size and air movement influencing those droplets. So that's some technology that is available that's becoming more widespread. Really where our biggest technology is occurring is what we use to evaluate vaccination. And some of it is actual technology advancements, and some of it's just using tools that we have available in a more efficient way. As I mentioned with in vivo vaccination, what you need to do each day is ensure the cups are clean, make sure the needles and the punches are coming out and releasing vaccine. And you can do that with these egg trays, these vaccine plates. This was sent to me by the company that owns Embrex, right? So you put one of these trays through the Innovo injector, you should see vaccine. But if you look right here, you see there's no dye, no vaccine being dispensed. So that's going to tell you that something's wrong with that individual needle, punch, cup, hose, pneumatic system. Something is happening in that individual piece. And so that needs to be checked, or every egg in that position is going to get missed through the vaccination process. And again, with recombinant vaccines, they don't spread bird to bird. So that's going to be very important to ensure that that works properly. For spray vaccination, again, it's very dependent on setup and operation in the hatchery. And there's not a great way to check in real time in the hatchery, okay, did that vaccination work or did it not work? You have to kind of ask the chicks a little bit later in life. But there are a few things you can do in the hatchery that will give you a pretty good indicator. One thing I really like to do is use plexiglass sheets. And I use these plexiglass sheets, I put it on top of a chick basket, and I run the chick basket through the spray vaccination cabinet, and it really shows me what the spray pattern is for that cabinet. All right, here's an example. If you just use chick paper, when the chick paper gets wet with your vaccine, it just looks like wet chick paper. But using a piece of plexiglass, you can actually see a defined edge on both sides, depending on how many nozzles you have. You can see where the vaccine started. You can see how it finished. If you've got a tail here where the spray tailed off, you can get an idea of droplet size. You can see droplets here across your spray. Obviously, this cabinet was not set up properly. This was a poor setup. So you'd want to adjust your pressure. You want to adjust your nozzle size, perhaps, adjust your application volume until you get something that looks more like this, where you've got an even distribution side to side, front to back. The droplets are going to always be arranged. You're going to have small, medium, large, extra large droplets, but they should be evenly distributed across side to side and front to back. And then the great thing about a piece of plexiglass is you just wipe it off with a paper towel, you set it down, and you use it again the next time you change vaccine, or the next time you come back from break, or whatever it may be. So it's totally reusable as a one-time purchase. Another thing that I really like to use are thermal imaging cameras in the hatchery. Now, some of you may be using them already to look at your hatchers, your incubators, look at air movement, different hot spots and cold spots. But I like to use them when I evaluate spray vaccination. So for one, it can tell me the temperature of my vaccines. Are they in an acceptable range sitting out there in the hatchery? I can look at my chicks after vaccination. Do they look evenly distributed? The chicks, being very warm, are going to be nice bright yellow. The vaccine, even if you don't cool the vaccine at all, it's still going to be cooler than the chicks, and it gives you a nice contrast. But what I really like to use it for is to evaluate the spray pattern in my basket before I really spray any chicks, right? So you can just run baskets through the spray cabinet with or without the plexiglass and evaluate what my coverage looks like. How well does my vaccine cabinet start and stop? What does the timing look like? Am I getting coverage fully side to side, or am I off center in my chick baskets? And then you can do the same thing with chicks moving through the spray. That's actually the first thing I'll do when I come into a hatchery to evaluate spray cabinet setup, is I'll just turn my thermal camera on, stand over the vaccination line, and just watch, 10, 20 baskets of chicks could move through, and see if I can see any consistent patterns or consistent things within that thermal imaging that we might want to change. And then to follow that up, this can be true with any of our vaccines, with the Novo applied, with spray vaccinated, or with vaccines applied in the field, is doing vaccine surveillance, vaccine takes, as we call it. So actually going in and checking with the birds and asking, okay, did you actually get the vaccine that we gave you? Post-vaccination, depending on which vaccine, the timing will vary. Sometimes it's 7 days, sometimes it may be 2 or 3 weeks post-vaccination. But just taking a sample from the bird, most often you can take that, use a swab to do PCR and allow you to check the vaccine to make sure that you're actually giving the birds the vaccine that you think you are. And if you're not, you can go back and try to pinpoint what happened. So we use real-time PCR to monitor these vaccine takes, and that's where kind of the technology comes in at this point. Real-time PCR has advanced a long way in the last 10 years. We have an assay available to differentiate strains of different viruses. Let's say with bronchitis, we can differentiate serotypes. In some cases, we can tell vaccine manufacturers one from another. In many cases, we can tell vaccine strains from field strains. There's an assay that will detect pretty much all the vaccines that we have available for use. So it's a really, really good way for you to evaluate your vaccine application. And just like ELISAs do for your older birds, doing vaccine takes allows you to develop a history for a certain hatchery, let's say, or for certain vaccines. Maybe you're trialing 2 vaccines against each other, and you want to see which one you think is going to give you the better protection, or which one's easier to use. This will give you a pattern and give you a history that you can use to compare and make decisions with your vaccine program. And so an example of what something like this would look at, again, with bronchitis, because that's where I spend most of my time, we've got a farm that was using an Arkansas vaccine and a DMV strain vaccine. And you can see the vaccine application here was not very good. A lot of negative birds within these samples. Different farms were using a Georgia 08 and a mass type vaccine. You can see here, all positive except one. The CT values, the viral load in that case was very similar. So this gives you, sort of a bad picture, and this would be a good picture. And you can then work with this hatchery or with this vaccine manufacturer to figure out, okay, why are these vaccines not being applied correctly, or why are the birds not getting it correctly? So to summarize, not a lot of technological advancement in vaccination practice or equipment over the last 30 or so years, but we're seeing it move into the market now. Some things are coming. There are tools available, the thermal imaging, the real-time PCR that we can use to ensure we're vaccinating properly. And then a quote from my good friend, Dr. Eric Shepard, you always have to inspect what you expect. And don't just think that everything's being done properly because it looks right. You actually have to go in and, evaluate a little bit to make sure that you're doing it properly. With that, thank you, and I'll be glad to take any questions.
Thank you, Dr. Jordan. We got some questions. Does large spray droplet cause chickens chill?
Excellent question. So the droplet size itself doesn't have anything to do with chilling, but volume, changing the volume, if you were at 7 ml, let's say, and then you went to 35 ml of volume, yes, that is going to cause some temperature fluctuation in your chicks, just because you went from a very small to a very large volume. In my experience, what I found is that, and we've done some chick temperature evaluations, the chick body temperature actually is more influenced by the way the chicks are managed after vaccination than by the vaccine volume itself. I work with a lot of companies that use 14 ml, 21 ml, even up to 28 ml if they're doing multiple types of vaccines together and don't have issues with chick chilling. So I would say if that is a concern, I would look more to your chick holding room after vaccination, how your fans are placed, what is the temperature and relative humidity in those spaces for as far as chick chilling.
Is the in ovo injection usually occur in the air sac, or it can be done in the yolk sac or the amniotic fluid? And if so, how can we ensure that we in the target area?
Right, great question. So the in ovo injection is not in the air cell. It goes through the air cell, through the membrane, and it goes down into the amniotic fluid. So for in ovo vaccination to be effective, it has to deposit the vaccine either in the amniotic fluid or sub-Q, actually poking the embryo itself. And there has been a lot of work done by the in ovo machine manufacturers to ensure that the depth of the needle, the rate of injection, and all that is standardized so that occurs. And I do believe the numbers I remember is 97 to 99% of all the embryos that go through are injected properly. But that is something that you can analyze that on doing some breakout residue analysis, post-hatch, opening some embryos that didn't hatch because those vaccines have a dye in them. You can see where the dye is inside the egg and evaluate that for yourself as well. But the companies do pay a lot of attention to that, and they do routinely monitor that with the machinery.
For the injection vaccination needles, do we need to change that after a couple of injections?
So there should be a standard protocol for when needles and tubing should be changed for injection. What that interval is, I don't know that there's a set standard. I would need to refer to one of my colleagues that has done some more work with field vaccination crew. But if that's a question, if that's something that you're interested in, I'll be glad to try to find that information and get it to Lee Long, and he can distribute to the group.
Okay, sounds good. And if you have any question in future, please feel free to reach us. I will forward your question to Dr. Jordan. Thank you very much again, Dr. Jordan.
Thank you.
Okay. Our next speaker is Dr. Yang Zhao. Dr. Zhao is an assistant professor in the Animal Science Department at the University of Tennessee since August 2020. Prior to that, he was an assistant professor of agriculture and biological engineering at Mississippi State for 3.5 years. Dr. Zhao's research focuses on smart poultry farming that addresses challenges in poultry production regarding sensoring, automation, behavior monitoring, welfare assessment, disease prevention, and environmental control. Welcome, Dr. Zhao.
Thank you, Dr. Chai. Let me share my screen here. Okay.
Yeah.
All right. So can you see my screen well?
Yes, very good.
Great. Thank you. I'm Yang Zhao, I'm an assistant professor of animal science at the University of Tennessee. So I've been working on poultry for some years. My research, so initially my research focused on environment management for poultry. So looking at the thermal environment, air environment in poultry houses, and also the air emissions. But later on, I became very interested in the new technologies and was amazed by kind of how much these technologies can do to improve the animal production and management. So that's why I started to working on precision poultry farming 4 years ago. So today I'll share with you some of my experience regarding precision poultry farming and some example projects from a research team. So first, let's look at the development of precision livestock farming research in the past 20 years, because the PLF probably something more familiar to us. So this figure here shows the number of hits I got when I searched for precision livestock farming in Google Scholar. So the results are categorized by years. So these results include publications with precision livestock farming in their text. So, but do not include the patterns. Okay. So I got total about 3,300 hits, of which only 8 were published before 2000. But after 2000, the PLF publications just increased exponentially. So the PLF really started gaining its momentum since then, and is a hot topic right now. It's just my preference to use the Google Scholar, but I guess you will get a similar trend if you use other database. So now, how about the precision poultry farming? So in this figure, I just added another category that shows the number of hits I got when I search both PLF and poultry as the keywords in Google Scholar. And the results of poultry research are showing in red here. So again, we don't see many hits before 2000, but after 2000, the precision poultry farming follows a similar trend as PLF. Now, this figure here shows you the weight of poultry research in all PLF publications. We can see that less than quarter of the PLF publications were about poultry or mentioned poultry before 2006. Okay, so considering the volume of poultry production in total livestock production, a quarter or 25% sounds a little bit low, and that's about right. It appears that the PLF in poultry sector lags behind some other sectors like the dairy cattle. The dairy sector has a much longer history in PLF applications than the poultry sector. For instance, the first widespread applications of PLF could be traced back to 1970s when the individual electronic milk meter for cows became commercially available. But in recent years, we can see that the poultry sector starts to catch up a little bit, weighing about 35 to 40% of the overall PLF publications. So you may have already realized that I mentioned precision poultry farming or PPF a few times. Wikipedia defined poultry as part of livestock, but USDA defined livestock are animals producing red meat. So poultry and fish do not belong to livestock. So it seems the concept may go either way. Therefore, when we deal with the precision farming for poultry, we could hear people saying different terminology like precision livestock farming for poultry, poultry PLF, precision poultry farming, precision poultry management. Okay, so I just use precision poultry farming or PPF here because it's short and you know what I'm talking about. So when I tried to find more information regarding precision poultry farming, I found an article that published by University of Oxford and University of Bern. So this article reviewed 264 reference publications regarding precision poultry farming and provides us great information to get a big picture of the history and the status quo of PPF. So they summarize these publications by country, income, technology used, bird type, research goal, and the parameter measured. So for instance, most of the publications were from USA, Belgium, and China, and majority focused on broilers and their health and production. And the popular technologies used were sensors, camera, microphones. Okay. So what is very interesting is that the vast majority of the study described prototype systems, and less than 5% of the studies describe the commercially available system. So this is understandable because the commercial products go after patents, not the publications. And another reason is that the nature of research is to test the prototype in lab condition before applied to field and commercialize the product, right? So, but on the other hand, we are really lack of products that are available for poultry producers. Okay? So if we agree that the final goal of PPF is to develop a system to improve poultry production and to help the poultry producers, we still have a very long way to go. So what we learned from these results. So first, the PPF research is not confined to a small number of countries. So contributors to publication were from 40 different countries. Okay, so US, Belgium, and China produced the most publications. So US and China are the major player in poultry meat and egg production in the world. And it is logical that these countries are interested in developing systems or technologies that could improve the poultry farming. So Belgium is the country with the early PLF researchers who are still active right now. We also see the PPF research is unbalanced income-wise. So there were no authors affiliated with low-income countries. And the majority of publications were authored by at least one author from a high-income country. So the PPF research used a variety of technology or devices. The majority of the precision poultry farming involved the use of sensors, including both sensors for environment monitoring, as well as the wearable sensors like radio frequency identification and inertial measurement unit. And the secondly used the technology was the camera. So 2D camera, 3D camera, thermal camera have all been used. The majority of the precision poultry farming research has focused on improving bird welfare, probably because of the increasing concern on animal welfare in the past decades. And most of the PPF research look at the bird locomotion and vocalization responses, but it's also covered many other behavior and welfare responses like perching, nesting, feeding, drinking, feather coverage, foot pad condition, etc. So that's about an overview of on the PPF. Now let's move on to some example PPF research and applications that my research team has been working on. So flock uniformity is one of the big concern of the poultry producers. So the uniformity could be related to body weight of broilers, egg production of layers, and bird welfare conditions. Okay. So my research team has been using RFID system to monitor individual broilers, feeding and drinking behaviors to understand the behavior uniformity. Okay. So basically, we put the RFID to the neck of the bird. So each tag has a unique ID, and when we place the RFID antennas at the area of interest, in our case, that's the feeder and drinker. So whenever attacked birds come to eat or drink, we just monitor it. Okay, we can track it, and then we could know which birds are at the feeder and drinker at a certain time, and which feeder and drinker they are using, and how long, and how often these birds are using these resources. Okay. So there are also some standards out there specifying the feeder and drinker space need for poultry production. For instance, 1 nipple drinker here is good for 10 to 12 broilers, and 1 tube feeder is good for 40 to 80 broilers. Okay. So with our data collected using RFID, we could be able to help set these standards from the bird behavior standpoint of view. So I have to say that RFID is not a plug and play system for poultry application and also for other animal application. It requires validation and modification. Okay. So for instance, the sensitivity of the RFID tags may vary. And this figure shows the maximal reading distance of 50 tags from the antenna. And you can see that large variations among these 50 tags, and one tag could be read, let's say, 60 centimeter above the antenna. And some tags are read, can be only detect, let's say, 40 centimeter. So, and these were the same batch of tags from the same manufacturer. Okay, so the tag sensitivity is one of the things you may want to pay attention prior to your animal test. We also modify the electromagnetic field of the antenna. So like in this situation, we use a square antenna to register birds eating at the round feeder. Okay, so we need to block the electromagnetic field of the antenna at the corner using metal sheet with a center hole. Okay. So actually, we also test the effect of water pack to block the electromagnetic field at the corner, but the metal sheet just worked more effectively and easily than the water pack. So this figure just shows the electromagnetic field after modification. So for the feeder antenna, you can see that the electromagnetic field at the corner was well blocked. Okay, so this helped us to register only the birds eating inside the feeder, but not those walking around the feeder. Okay. So because the metal is not a friend of electromagnetic field, so this means the performance of RFID could be affected when you use them in an environment with metal materials like the bird cages or metal feed trough. So be aware of that. So also, it is important to optimize the placements of the antenna. So here we look at 3 placements of the drinker antenna, including kind of vertical placement at a higher position, vertical placement at a lower position, and the tilting placement at the lower position. So, and we check the accuracy of registering drinking birds for this antenna placement. So this test might look minor, but it's really helped us to develop a reliable system for bird behavior monitoring, so we could explain the data we got eventually. So like whether the difference was from the bird behaviors or due to the system setup or limitations. Okay. So a big concern on broiler welfare is the bird walking ability. So the modern broiler is bred to grow fast in meat production, but their skeleton development cannot catch up well. Therefore, we see birds having walking problem, especially at the late production stage. Okay, so we use the inertial measurement unit, or IMU, to monitor individual birds' movement in our lab and test different treatments to improve the walking ability. And IMU has the has an accelerometer and gyroscope to measure the bird movement and turning that can be translated into the walking ability. So this figure, the figures on the left shows you how we attach an IMU to a broiler. So basically we put the IMU in a small pouch on a chicken harness, and we let this bird to wear this chicken harness. So the figure on the right shows the acceleration of a bird in 3 dimensions, X, Y, Z. And these accelerations show different patterns when this bird was walking, was resting, drinking, and feeding. Okay, so this means we may also use this IMU data to classify the bird behavior. Okay, so one of my graduate students, Xiaoyang, who is also here today, is working on the automatic behavior classification using IMU and machine learning. So this body mount sensors like IMU and RFID are good tools for research, but for commercial production, it would be a challenge because the cost and the labor needs on mounting and adjusting this sensor. So because the birds are just growing very fast, the broilers are growing very fast, we have to adjust the size of the chicken harness, say, twice every week. So my team also use different type of cameras for precision poultry farming research. So in this case, we are trying to track individual birds' movement using a 2D camera. So you can see that most of the birds were detected and separated. The algorithms occasionally misidentify other objects as the birds, like this one, this waterline here was recognized as the bird. And also when the birds are touching each other, it's hard to kind of segment the individual birds. So here we use kind of a low stocking density just to explore the possibility of individual birds tracking. But under regular stocking density, individual bird tracking using 2D camera could be a challenge simply because the segmentation of the birds due to high stocking density or touching between the birds. Perhaps a 3D camera could improve the tracking under regular stocking density, which could be worth a try. But anyway, the camera-based system is one of the few commercialized products for poultry production. I think some of us may know some commercial production like Dynamic and the Chicken Boy. Right? So the current gait score assessment method requires trained experts to manually score the birds. Okay, so while this method is still a good standard, it is, however, difficult, subjective, and time-consuming when implemented in the commercial farm. Right, so the broader gait can also be assessed using image processing. So here we are monitoring the broader activity and the distribution, which can be used to estimate the gait score. So the upper left video here is an original top view video in a commercial farm with these green boxes tracking the moving birds. And the upper right video shows the moving of the broiler pixel. So with this information, we can kind of determine the bird distribution and their activity index. Okay? So which are showing at the bottom two videos here. Okay? So in these two videos here, a square with darker color means there are more birds or higher activity in that area. Okay? So determining the distribution and activity is the first step. And down the road, we will kind of develop a model to predict the gait score using these two parameters together with body weight and age. So this will enable us to develop automated system for kind of real-time or semi-real-time gait score assessment system for commercial production. So the camera can also be used for automatic behavior monitoring. We probably know the 5 freedoms of farm animal defined by the Farm Animal Welfare Council in UK. And one of them is the freedom to express normal behavior. Also, the National Chicken Council stated in its welfare guidelines that birds should have enough space to express behaviors like dust bathing, preening, eating, drinking, right? So here we look at the 2 comfort behavior, including stretching and preening of the broilers and the laying hens. So basically we use deep learning model to identify the stretching and preening birds in our lab. And we also look at where they prefer to perform these behaviors. So these two, these heat maps here shows the spatial preference of birds to perform these 2 comfort behavior in the pens. So the warmer color indicates places where the birds prefer to perform these comfort behaviors. And we also mark where the feeder and drinkers are. So this information could help us to evaluate and optimize kind of a welfare-oriented housing system or management practice using bird behaviors as the indicators. So we could also use the image processing for welfare assessment. Like here, we were identifying foot pad dermatitis based on the color difference between the chicken feed, between the health foot skin and the dermatitis area. Okay, so poultry producers do not make much profit from chicken feed in the U.S. Yet there's a huge market overseas for good quality feed, but they have to be good quality. So nobody wanna buy a chicken feed, with dermatitis issue, right? So we also use the thermal image to evaluate the feather coverage of the birds. Okay, so in the color thermal image, a red area represents less feather coverage, and the green-blue area represents better feather coverage. So the feather coverage is not only the welfare issue, but also a production efficiency issue. So less feather coverage may lead to more heat transfer between birds and the environment, right? So in some situation, more heat transfer means worse feed conversion. But in other situations, less feather may be beneficial for instance, relief of heat stress, right? Now, how about combining the thermal and visual images together? So this is a FLIR dual arc camera that can take the visual and thermal images in pairs. So in the visual image, basically we see everything. the thermal image can differentiate the objects with different surface temperatures. Okay, so we use this camera to take pictures of a group of live and dead birds. So we see all the 6 birds in the visual image, but only the 4 live birds in the thermal image, because the surface temperature of the dead birds was close to the background temperature, let's say a few hours after death. Okay. So, and then we did some basic image processing on both images and subtract the thermal image from the visual image to identify the dead birds. And so this is just one example of using visual and thermal images together. Now, the robot have been developed and commercialized to assist flock maintenance in poultry houses. For instance, the robots, this one here is used to migrate the birds and encourage their activity. And this one here is used for disinfection, vaccination, and scarifying the litter. And the one at the bottom right corner is a mobile camera system that can collect the visual and thermal images for bird health inspection. So my research team also has also been working on the robot to address challenges in poultry production. For instance, the laying hens in cage-free house may lay eggs on the litter floor instead of nest box. Okay, so the eggs laid on the floor have to be collected manually by workers. That's laborious, time-consuming. So we try to train the laying behavior using a ground robot. So basically, we run the robot periodically on the floor and tell the birds, okay, hey, we don't want you to lay eggs on the floor. If you need to lay eggs, go to the nest box. Okay. So this experiment was done in a USDA lab, and we compare the floor egg rates in 2 treatment groups versus the control group. For the control group, basically, we don't use robot. Okay, so for the 2 treatment group, we operate the robot for 1 or 2 weeks in the early stage of the experiment. The result is showing in this figure here. So basically, we operated the robot in week 35 and 36 of bird age. So the blue curve is the floor egg rate in the control group, no robot, okay? And the red and the green curves are the floor eggs in the 2 treatment groups with robots, okay? So, the floor egg rates decreased for all the 3 groups over time. But it seems that the floor eggs rate dropped slightly faster for one treatment group, this is a green one here, than the control group in the first 2 weeks. But we still need to do more analysis to confirm that. But if we look the overall, these 3 curves, okay, the robot effect on floor eggs reduction is not significant. Okay, so they have kind of a similar trend here. So this probably means that operating a ground robot has a limited effect on correcting floor laying behaviors. And to solve the floor egg problem, in cage-free housing system, we may need some other solutions. For instance, using combination of robotic arm and machine vision system for automatic floor egg collection. Okay. To develop that kind of system, the first step, of course, is to develop image processing models that can identify the eggs on the floor. So the lighting, we know the lighting in the commercial cage-free house is not uniformly distributed, but the algorithms that we developed can successfully detect the brown eggs, white eggs under 20 lux, at 5 lux, and also below 1 lux. So we cannot even see the brown eggs in this image here, but the algorithms can still find those eggs. The robots test I just mentioned were performed at lab environment. So for their applications in commercial poultry house, some people express their concern about whether this robot would induce stresses or fearfulness to the birds. So in another study, we looked at the poultry responses to ground robots and drones. Okay. So you could see in these two videos, you could see that the birds indeed walk away, okay, from the ground system and the drone, but they did not act like crazy. Okay. All right. So the future of PPF, could AI be the future of PPF? I would say that's very likely. So we are seeing exponential increase of AI application in precision poultry farming. And NSF and USDA worked together and solicited proposal regarding AI-driven innovation in agriculture and food system. And poultry production is definitely covered within that scope. And the collaboration between these two parties highlights the importance of AI in agriculture systems. And also we see the challenge in PPF. First, the cost. As said earlier, the body mount sensors are too expensive to be used for poultry producers. Okay, so one passive RFID tag is about $5 to $10, and one IMU could be $50 to $250. So, and in order to get statistically sound data, you will need many of these sensors for the commercial farm, right? And also, if we think about the labor that need to adjust and mount these sensors, it just makes the body mount sensors impractical to be used for commercial production. And the most feasible and affordable technology for commercial poultry productions are cameras and microphones. Okay, of course, you will need a computer to process the big data, like the image and the audio data collected by these sensors. So a high-end computer that can efficiently handle this machine learning, deep learning models could be a few $1,000s. For research, thousands of dollars may be not a big deal, but it could be quite a big investment for the commercial broiler growers, considering their thin profit. So there are many companies offering affordable cloud computing services that can save the budget for a high-end computer and allow the farmers to pay a low monthly fee or based on the computational resources usage. Okay. So another challenge is the performance. So we do want, so although the poultry farming is not very strict science, not rocket science, we still want some decent performance on whatever PPF system are designed for. So also we need this PPF system to be robust enough to handle the harsh and complicated poultry environment. So in addition, we must build the trust with the poultry producers. So the poultry producers are extremely care about how the data are going to be used, especially for the image and video data. So we are probably aware of a few instances that some video data collected from the chicken or from the poultry house were used against the producers. So communicate well with your collaborative poultry producers regarding the way of data use and follow the agreement. So last but not least, the safety is the operation of PPF system like robot, ground robot, drones should be safe to the birds. Okay. The last thing we want to see is the bird are injured by this system. And also the bird should not be stressed by this system. So we could understand this stress by looking at their mortality, their avoidance distance, and some standard stress indicators like corticosteron and H&L ratio like that. Now, so I would like to thank my research team because they are the people, they are the guys who really work at the front of this research. Okay, so and I also like to thank my collaborators at USDR's, Mississippi State, and also the University of Tennessee. So I also want to extend my acknowledgement to my founding agencies, including USDR's, Mississippi Agriculture and Forestry Experiment Station, FFR, Ag Industry Center, and US Poultry and Egg Association. Of course, this research cannot be done without the support from poultry producers. I'd like to thank Pico Food, Tyson Food, Pilgrim, Kilman Food, and Cook Foods. So with that, that's all my presentation today. Thank you very much.
Thank you, Dr. Zhao. We got some questions.
Yeah.
Okay. Are those low frequency RFID tags?
So we are using ultra high frequency RFID, UHF.
Does chicken having harness on the back will increase bird pecking behavior? Should be pecking behavior.
Yeah, we noticed that for the first, 24, 40, 48 hours, the birds really have some kind of not normal behaviors. They try to get off, take off this harness, but after that, they will adapt that after 48 hours. So, yeah.
Okay. You started the robot at 34 weeks of age, when hens were at peak laying and already had a floor laying problem or not? At the 34 weeks of age.
Yeah, so we got this. So yeah, initially we planned to get the bird, let's say 22 weeks old when they just start to, increase the egg production. But eventually what we get is 30, 33, 34 weeks of birds. So yeah, but our result can also show, whether if the birds already has a layer, floor laying behavior, whether robot could be helpful to correct that behavior. So we see some trend. Maybe if we run the robot for the first 2 weeks, it has some little effect there. But again, we need some more statistical analysis on that. But if we look at over the long term, really it's not very helpful to use the ground robotic system to correct this floor laying behaviors.
Okay, thank you, Dr. Zhao, very much again.
Thank you for having me today.
Our next speaker is Dr. Prafula Ragmi. Dr. Ragmi is an assistant professor in the Department of Poultry Science at the UGA. His research and extension efforts focus in the area of applied poultry welfare. His current projects involve reducing carbon damages in cage-free hen houses, testing technology-based tracking systems for laying hens, and understanding the role of growth rates in predisposing broilers to lameness. Welcome, Dr. Ragmi.
Thank you. Let me see if I can share my screen. Can you hear me well?
Yes.
Good afternoon, everybody. Thanks for this opportunity to present here. Also the outline of what I'm going to present today. So we'll talk about the initial animal welfare definition and how it has been incorporated into the consumer-driven society. And then we'll talk about the need for objective assessment of welfare and how we can do a holistic examination of welfare issues. And then the last component, we'll talk about how we can use technology to integrate the three major components of welfare. And looking at some of the presentations that have already been conducted here, we might be looking at some of the overlapping information, but I hope you'll bear with me and then hear my point of view. So we are all pretty familiar with the 5 freedoms of welfare that was put out by the Bramble Committee. So there are some, over the years, we have had some debates around is attaining those 5 freedoms on an absolute basis possible. But there is no debate on our role or humans' role on ensuring animal welfare. And that has been the same model adopted by American Veterinary Medical Association as well. So if over the years, then Dr. David Fraser came out with these 3 component basis of animal welfare, and which is for, in our case, for a bird to have a good state of welfare, it has to be a perfect combination of its emotional state, the natural living, and the basic health and functioning. So the basic health and functioning component, we have made pretty big strides on that, controlling diseases, using biosecurity, vaccinations, although there are still some problems that are existing. And then now, in the last couple of decades, the debates or the research advances has been surrounding around how we ensure that the birds that live with us are expressing their natural behaviors, and then we're providing them with effective state. So what I'll try to do in this presentation is give you an overview of where the consumers are coming from in this angle of animal welfare. So this is a short snippet of a consumer survey that we did with students and some consumers outside the university. So this was a class project, but the results here align pretty much with a bigger survey that is conducted and published in the literature elsewhere. So we found that high percentage of consumers, almost 75%, are willing to pay more for animal welfare certified eggs or chicken. And almost the same percentage of consumers, though, don't verify the label on food that was put about, or the information that was given about the human treatment of animals. Majority of the consumers picked USDA certified label as measure of animal welfare. However, we all that USDA label is primarily related to food safety implications of the product. So there is an increase in online grocery shopping habits, and that has been even increasing more because of the pandemic situation that we're in. And then the interesting situation, or the interesting information, at least for me, was that the survey participants did not identify university or the animal industry as the most likely sources to get information on animal welfare. So it seems like there is a lot that we need to do on our end on that one. So the reason that I'm presenting you with that consumer survey was to look at how the pendulum of animal welfare related changes has come about in our production system. So on one side, we have poultry producers and allied industry. And when I'm saying one side, I'm not trying to separate the sides, but to say the predisposition towards animal welfare related changes. And on the other side, we have consumers, animal rights group, and then there are other factors as well. And as the researchers, we're trying to bridge the gap as well as trying to provide the information. So this again brings us back to the objective information that we need so that we can bridge the gap between both groups and promote animal welfare. So when we talk about the assessment of animal welfare, we know that most of the welfare issues that the poultry industry faces right now are multidimensional. So there is not just one particular factor that brings about any welfare issues. And as a result, there are several indicators that we can measure. However, we all agree that those indicators should be valid, reliable, and feasible. And then traditionally, a combination of resource-based or animal-based measurements have been used to assess welfare. So the conventional methods of animal welfare assessment, as pointed out by previous speakers as well, it can be time and labor intensive. And because of subjective nature of some of the parameters we intend to measure, some of the results that we get might be error prone. So that brings us to the need of how we can use measurable or quantifiable parameters to look at poultry welfare issues. And then, so I'll take a few examples in laying hen and then in broilers to look at how objectivity has helped or has been incorporated in assessment of animal welfare. So one of the biggest area of discussion right now is the case-to-case free transition of laying hens and how welfare can be assessed or monitored in those systems. So initially, when we moved from case-to-case free system, one of the main reasons was the skeletal issues that the birds in the conventional cases were facing, the osteoporosis in those layers because of the lack of physical movement and high egg production. The hens were under constant negative calcium balance. And then at that time, the fracture of humerus or the wing bone and the tibia was reported to be around 5 to 15% by slaughter. And this was around early 2000s. So at the processing plant, the fractures rate in those birds were a little bit higher, up to about 25%. And the image there shows you some of the micro CT scans that looks at the cases of osteoporosis outlined by these big open areas of or vacant areas without bone mass. So then the next big question that we tried to tackle was if we let chickens run around and if the chickens have more opportunities to do physical activities, will it result in improved bone parameters? And then the data shows that it actually does. So when we looked at, so in this graph, I have inertia on x-axis and the bones, tibia and humerus on so inertia on y-axis and tibia and humerus on x-axis. So inertia just measures the bending resistance when a force is applied to the bone. And as you can see, those blue bars that represents the birds that were kept in aviary houses or the cage-free houses had increased resistance to bending than the birds that were kept in the conventional cages represented by the orange bars. And the same result was seen for the stiffness of the bone or the density of the bone in common terms. So the density of the bones were higher in aviary systems as well. So the question was the skeletal problems of cages resolved by moving to cage-free system? And to a larger extent, yes, but only for the fractures of humerus and tibia. And then we started looking at the problems of keel bone fractures or the breastbone fractures in these systems. In these pictures that you can see different kinds of deformations and fractures that you can see as a result of keel bone fractures in laying hens. The bone on the right looks like probably closest to the normal, but the other ones you can see multiple fractures, big deposition of fracture callus materials around the healing side and gross deformations of the bone. So when we talk about technology then, so initially a lot of studies that were conducted in assessing laying hens for keel bone fractures were using a manual palpation technique. And the process was easy enough and it could be done in a large number of birds at the farm. But what it was not allowing was like underlying mechanisms behind those fractures. Where the fracture was present, was it more prevalent in one area of the bone? How the fracture develops over time in the bird? Is there any critical time points related for the birds to get those fractures? So we started looking at CT scanning techniques where we could observe multiple birds in a longitudinal scan throughout their production life and look at the development of those bones and the progression of fracture in those bones. So these scanning were conducted without any use of anesthesia. So one of our technicians that designed a body cover or a jacket that you could put the birds on with breathable material, and then the birds will stay quiet during the scanning process. So if I can orient you towards these images here, the first bone here is of a bird that is at 16 weeks of age. So it seems like the piece of the bone is broken off, but it just means that the bone was partially cartilaginous, and then it was not detected in the CT. But as the birds grow older, you can see the fracture was already starting to happen at 24 weeks with some deformation. And then the bone kept remodeling around the fracture. And at 52 weeks of age, you can see a pretty severe deformation. What this allowed us, or this use of technology allowed us, was to look at different effective strains on kill bone deformities in a more clear manner. So we found that there are some differences between strains, but no matter whether it was a brown hen or a white hen, the prevalence of fracture was still around high 80, 90%. And this was again in experimental setup. And some of those fractures might have been incurred while trying to catch and scan the birds for the process as well. But what we did was we ended up developing these three-dimensional models of kill bones, and then devised a way to look at the fracture in a more finer detail. So it also allowed us to look at the differences in housing systems, in different housing systems. And as you can see in this graph here, you can see almost the birds during the pullet phase do not really incur any fracture, as indicated by no or less fracture at 18 weeks. And then fracture is almost about 25 to 30% already at the 26 weeks of age. And then it increases as it go over. And the surprising thing was the fracture was also quite higher in the conventional cases that we saw. And then previously, but again, if you look at the severity of the fractures or the locations of the fractures, then it was different between the housing systems. And you were not able to find or palpate some of those minor fractures towards the tip on the conventional cases by just palpation. So we also found that most of the fractures in conventional cages, as indicated by these orange bars, were at the caudal tip of the kill bone, whereas the majority of fractures in aviary system or the cage-free birds were towards the caudal 1/3 of the bone, and some in the middle portion of the bone. So it indicates that even though the prevalence might be similar in different housing systems, the underlying mechanism or the response, once the remodeling response to the fracture might be quite different. So in addition to that, we also identified it was not just the housing system or the genetic strain, but different stress that could result in inflammatory signs around the intestine or changes in the gut microbiota could affect bone mineral content and the metabolism as well. So in this group, there were two groups of birds. One, the blue bars represent the birds that were subjected to catching and handling stress and the transportation stress. And the orange bar represents the birds that were left undisturbed towards the initiation of egg-laying period. And you can see the increase in inflammatory markers of pro-inflammatory cytokines such as IL-1 beta and IL-10 going up in the birds 1 week after stress in those blue bars, as represented by those blue bars. And then those changes were in correspondence with a decrease in bone mineral content at 24 weeks of age in those birds. So what this brings us to is, again, to the point where we know that welfare issues are impacted by multiple factors, and there is a need to look at this in a more objective manner. So that was about just using one of the technology of imaging using computer scans, tomography scans to look at fracture, and how it has given us more information to tackle this problem in a greater detail. But there are other issues in welfare issues in meat birds as well, and then I'll try to give you some examples of the technology that has helped assess those issues. So when we look at the traits that are used in selection for broiler or turkeys for meat production, it usually focuses on fast growth, efficient feed conversion. However, problems such as leg disorders, other behavioral issues come quite low down the order. And what that has caused is multiple problems with foot and skeletal system and foot lesions. So you can see these angular deformities, varus valgus deformities in turkeys and broilers. And the picture here, you can also see this white cartilaginous plug refers to tibial dyschondroplasia and chondronecrosis. The foot pad dermatitis, also shown by previous speaker. A lot of these problems arises, and the gait assessment method that we currently use in meat birds are quite descriptive, as you can see from the chart that was developed in the mid-90s and early 2000s. In the turkeys, a lot of time a 3-point scale or a 4-point scale has been used. But if I try to read some of the description of the gait parameters, it might be quite confusing at first. So say like a normal gait was defined by smooth, fluid locomotion, and the foot is furled while raised. So these parameters, while it sounds easy to differentiate, can be quite confusing and quite subjective. So the same thing with other common welfare issues on how we identify them properly and track them properly so that we can understand the underlying mechanism of those bones, of these problems. So some of the common meat welfare issues were early starvation in chicks and poults, big treatment and toe trimming. In turkeys, aggression is a big problem, feather picking and skeletal issues, and the dynamics of the birds in large group sizes. So when we look at some of those welfare issues and how they are connected to each other and how multiple factors play into those and the use of technology to assess them. So let's look at if we can combine or integrate some of these technologies to look at the welfare issues in a finer detail. So the challenges and opportunities that has arisen with the modern poultry production systems can be reflected through this video. So if you look at this video closely, you can see the birds in this large group indulge in different kind of behaviors, some normal, some abnormal. But the challenges here is how we separate those and how we track those, right? So you can see the birds on the perches, you can see the birds, some never moving, some birds constantly jumping up and down the system. And some of these young pullets are involved in some playful behaviors towards on the litter area as well. So what this means is the changes in the housing or having birds in an extensive environment means that the more space are provided in bigger colonies. And then the system are complex with inclusion of enrichments, nest box areas, litter areas. So ideally in these systems, instead of farmer managing the birds like they used to in the conventional cases, the birds are managing the farmers. So in other words, you have to pay attention, close attention to what the birds are doing, and then only you can ensure that they are producing well, and then their welfare is ensured. For example, the problem of feather picking that we have been discussing quite a lot, and we saw methods of tracking those featherless and feathered areas in the previous talk as well. So those problems start out with only few birds initially in a big flock, but it only takes 48 to 72 hours for those abnormal abnormal behaviors to spread throughout the flock. So the key is identifying the changes in your flock and then responding to those changes. So dynamics of bird behavior and physiology could provide clues to effectively monitor the welfare of individual birds, as well as early diagnosis of disease process in the flock. And that whole statement is the basis of the precision poultry farming if we look at just welfare of the birds. So the positive of using technology to look at these problems is it gives us real-time and continuous information and data that can help us to advance knowledge on animal health and welfare. It fosters interdisciplinary collaborations. As I see a number of participants in these workshop as well, or a seminar as well. We have engineers, we have animal welfare scientists, nutritionists, physiology and management scientists. And then we've all realized like only by coming together, we can solve some of these issues. And then if the way that technology is advancing, we talked about the price and cost associated with on-body and some of the implantable sensors, but the hope is in the near future, those would be cheaper and then scalable to commercial systems as well. So a lot has been talked about some of the existing technologies such as environmental sensors, vision and acoustic sensors, tracking sensors, and physiological sensors. So I'm just going to show you some examples of how they have been utilized. So the first one is a machine vision-based method for monitoring broiler chicken floor distribution that was conducted by Dr. Lee Long Tsai in our group at UGA. And then that was to use the machine vision tool to look at broiler space occupation in the housing system. So another study that they have used the acoustic parameters or the vocalizations as an indicator, or the early life distress calls as an indicator of production or body weight gain towards the later part of the production. Similarly, acoustic sensors have also been used to track the internal peeping stage on a hatching egg and how you can reduce or narrow the hatch window. So the movement sensor has been quite commonly used to assess animal welfare as well. So because movement or the lack of movement is an indicator of welfare status, because it relates to the skeletal problems, gait issues, breast blisters, and other problems as well. So traditionally in a research setting, pressure sensing mats or walkway were used to look at the asymmetry in gait or the force generated by each movement. Similarly, others GIS related sensor was used by Daigle to look at the movement of hens in a production environment, where she used Mica 2 dot stationary radio nodes throughout the houses, and then looked at the inter-individual variability and how much, like the temporal and spatial distribution of different behaviors that the birds were performing. So in our own cases, we have tested and validated and used accelerometers to look at movement of laying hens across perches and other housing equipment. These wearable accelerometers, as shown by the speakers before me, can be used to calculate different parameters associated with movement or gait, such as landing forces, height of the jumps, and the initiation and landing times. The results from these studies can be used to improve housing design by adjusting perch heights and locations. So, but we also tried to look at using these accelerometers, if the possibility of using these accelerometers on a farm level or on a natural level on the bird. So instead of trying to do more basic level calculations, we tried to see if we can develop a user-friendly method and just look at the asymmetry between the gait of right and left leg in a turkey by using 2 accelerometers, one on each leg. And then we validated that by using the pressure mat. So if you look at the turkey is walking with an accelerometer on the each leg, and then between the bird that had a normal gait and then a visibly impaired gait, we were able to see the differences in just the energy of the acceleration as the bird was walking from one movement to another. And those methods were validated using a pressure sensing scan, although it still remains pretty challenging task to distinguish between the early stages of lameness or the initial stages of score 0 versus a slight lameness and a slight versus a moderate lameness, but it was pretty easily able to detect lameness on a little bit larger scale. So this was just a preliminary study that we had completed, and we need to do a little bit more work on this. And then the another side that has generated a great deal of interest for me as well is if we look at those 3 components of animal welfare that we talked about, A lot of methods that we have discussed so far has looked at natural behaviors or the production side of things, but the affective state or the emotional state of the bird is still at quite infancy. So the idea was if we can use these small wireless implantable sensors that could look at heart rate and heart rate variability parameters, and these parameters have been associated with autonomic balance, nervous system balance of the bird, the vagal tone, and the balance between sympathetic and the vagal tone. So what we did was, and like we know, the cost associated with these sensors can be expensive, but there are ways to design and implement custom sensors that can continuously collect the data. So in this preliminary trial we just completed, we had birds that was subjected to catching and handling stress on the graph on the left-hand side that I'm presenting there for about 15 minutes every day for about 3 days. And then on the right, we have the birds that were left undisturbed. So when we look at the heart rate data from those birds, if you look at the time frame, we could see that the R to R interval, which is one of the heart rate variability parameter, was increased in the birds that were stressed. And then, but the data that is shown here, or the increase in R to R interval, is not while the birds were being stressed during the lifetime, but it was when the birds were during the dark hours, or when the birds were sleeping. So it gives us an indication that stress that the birds has experienced during some part of the day can be reflected in their heart rate at a later point in the day as well, and gives you an indication of some of the mental state. So, and as we talked, so this could lead to incorporating those affective states into our assessment of animal welfare as well. So lots of other software and mobile applications like iNemic, software for gait score in broilers, Vision to track individual animal activity in a pen, iWatch broiler and iWatch turkey. This kind of technologies has been developed. However, again, the need for a robust tracking system, like the previous speaker identified, is challenged because each chicken or each turkey looks similar to another. So the homogeneous population of the flock mates makes the visual tracking of behavior quite ineffective. There could be occlusions, some inanimate objects could be seen on the frame. And then the challenges with on-body sensors is sometimes aggressive pecking, and then those on-body sensors are able to collect very reliable individual level data, but we know we cannot put implants in all many thousands of birds, but how we can use the information that we generate from select individuals and use that to look at the welfare for the whole flock is another challenge. And then other sensors that have been used, like acoustic sensors, optical flow, they can generally predict the general flock level scenarios, but it does not, again, give you indication towards the underlying mechanisms of what is happening with the bird. And then we also talked about the challenges with data volume. So the RFID sensors that the other speaker was using, and then the RFID sensors that we are trying to use as well. Sometimes you get pages and pages of data from one bird in few hours, and then some birds don't really move at all. So there is this sheer volume of data and how to analyze and make meaningful sense out of it, and the affordability and applicability in real world scenario. So this is just an example. I think somebody asked the question earlier if the bird would be suffering from pecking if they're wearing a vest or a harness. This is just an example of how they react to it when the vest is first put on. So you can see the birds, they act like a person under intoxication, but this behavior usually lasts for about 30 minutes, and there is still some other birds being interested and try to peck at them, and then they'll try to get the vest off, but they usually settle down pretty okay after 24 hours. So which brings us to the last couple of slides of my presentation. So we've talked about ways that people have used to look at behavior, and ways that we're trying to look at some physiological indicators that goes with welfare. Again, the key point is how we combine or incorporate or integrate these different multi-sensing modalities or different sensors into one output, so that all three components of animal welfare is combined. So these wearable sensors, these implantables, these machine vision sensors, if we can combine that into one output and define them by time series, then that could identify or measure the intervention strategies that we use to ameliorate welfare issues in chickens. So if we are trying to look at, say, a putative model of how to look at the effect of growth rate on broiler welfare, the lameness status or the gait status of the bird should be ideally a combination of the behavior that is tracked by the cameras or the vision sensors, the wearable sensor that is giving an indication of the heart rate or the dynamic body movement, and then the CT scan parameters that you can look at, the angulations of the bone, and then the structures of the tendons and the ligaments as well, and how body surface area and body weight correlates with those measures. So with this, I would like to acknowledge some of the collaborators that I've worked with and some of my team here, and thank you.
Thank you, Dr. Ragami. For the time of reason, Dr. Ragami can answer one quick question.
Okay.
Oh, we got a question in the chat box. Broiler breeder usually pack feeding equipment on nest box, but some welfare concern group says they are hungry. Do you think any technology could help to define or assess welfare of this packing behavior?
So the situation with broiler breeder is the situation arises because most of the breeder pullets are kept under feed restriction regimen, and as a result, these birds are traditionally bred to have eggs that will eventually lead to the modern broilers with larger amount of breast size and thigh size. So when you do not give them feed regularly, they go through that through the process of hunger and frustration, and that is manifested in their abnormal oral stereotypies. So when they peck at the drinker, they peck at the feeder, that is just a manifestation of oral stereotypy. Traditionally, the producers, they try to look at a skip a day feeding program or some feed restriction, because they think if the birds are allowed to eat regularly, those broiler breeders, they will accumulate a greater amount of adipose tissue or fat mass, and the reproduction or the egg production capability will be compromised. So yes, there should be technology that will allow, because when you make, I think I've talked with this with somebody before, when the pecking, when a bird is pecking at a feed, it generates a different sound or a different accent than when a bird is pecking at the object. So just if you're just talking about tracking the birds doing these activities, yes, it is possible. But again, to look at the implications of if those behavior is affecting welfare, again, I go back to saying to my reason of incorporating physiological measures with those. So we can look at satiety measures, we can look at ghrelin compounds, other neuromessengers related to satiety, but you can also look at overall changes in the affective state by just looking at heart rate variability parameters as well.
Thank you, Dr. Ragami. For other questions, please contact Dr. Ragami, or you can send a question to me. I will forward them to Dr. Ragami.
Thank you.
Next will be the panel discussion. Dr. Abgad will be hosting the panel discussion. Okay, Dr. Abgad, the floor is yours. Let me add you as the host.
Thank you, Lilong, and it's my great pleasure to introduce the panel to you today. So we've compiled three very unique individuals with very different perspectives to talk through a lot of what we're looking at on application issues of technology into the poultry sector. So Simon Cohen will go first. Simon brings some perspective from a company that's been involved in developing those technologies as well as launching those into the poultry sector for several years. We have Dr. Doug Britton to bring an academic perspective on development of technologies and what that really means from an academic context into licensing and developing those launches. And we also have Dr. Cheng-Ying Lee, or Charlie Lee, who's faculty here in UGA Engineering, who's been much more involved in what I'd call precision ag applications into the plant sector. So very interesting and unique perspectives amongst the panelists today, and appreciate you all joining us for today's conversation. The way we're going to format this afternoon, each of our three panelists will give kind of an introduction on their views of issues around application of technologies from their own unique perspectives. So we're going to kick it off with Simon. Simon, just by way of introduction, Simon is the Vice President of MTech Systems. He's a native of Caracas, Venezuela. Received his bachelor's degree here in engineering from Georgia Southern University. Had worked previously with System8 in the Netherlands, designing poultry processing plants, and really then moved into one of the primaries for MTech Systems. And I'd say currently really looking to transform that company from where it is on a leader in agribusiness software here in the Southeast US into more of the global market space. So with that, I'm going to turn the floor to you, Simon.
Thank you, Dr. Applegate, and thank you, Dr. Chai. I appreciate both of you for the opportunity. And actually the entire UGA Poultry team. This is a great event, and so really interesting stuff, good meeting. So I'll go, and I'll go quickly because the idea is to stimulate a little bit the audience, I think, more than anything. So I'm going to move through really quick concepts, fly through it, give you about 10 minutes of this view. But first of all, for everybody to know quickly, MTech, we are one of the leading companies in the software technology industry when it comes to protein, and our mission is right here: lead a food revolution by supplying producers with the latest technology to help them improve animal welfare, increase yield and profit, while building really sustainable feeding growing population. Just for you guys to have a quick idea of who we are, we're working with about 97% of the market share. So about 60 countries, and I'll get to why this is important, 10 out of the 10 largest companies, and about 65% in the Latin American market share. Some of the partners that we work with are right on the screen, and I mean this because at the end, data is really what I want to talk about real quick. So these are key partners who we work with across the world, because probably you know this stat right here. Most of you know it, right? We got a growth population, 9.7 billion by 2050. But what that means is, of course, we all know we need to increase production, but we have a very limited space in Earth. Now, you know all this, everybody know this. What you may not know is that to maximize this production, to reach these goals, we need AI and IoT. We talked about it today, right? We need to advance on this data being reliable. But what the problem is that we're looking in 2022 that 50% of the companies, all our companies that we talked about, the producers, will lack sufficient AI and data literacy. That's the problem. So one of the challenges, or the biggest challenge, is really the data. But what's interesting is that there's $2.3 trillion in cost savings, 2.3 trillion if we do smart farming. Out of those 2.3 trillion, 250 billion can go to AI and data analytics. So huge potential to help these companies save. But at the end, to me, to try to get to the point, data and talent is really refined gold. This is the key to this journey. And it's tough. It's tough to get it. So for me, there's two key points. One that I want to touch on. One is these companies, the producers, the academics, if you want to get into this world, I think you got to build a platform that can be ready to handle these technology advances. So you got to embark in the journey, and you got to get going. And so it's the first sentence there. We must have the capacity and be ever ready to implement the right advancing technology, right? So we have to be in this quadrant of being more prescriptive and predictive, not looking at the back, not looking at the history, but trying to predict these algorithms and this technology into the future. The second one is IoT, AI, and cybersecurity. We cannot forget about cybersecurity. I think it's an important aspect of embarking in technology. What I mean by cybersecurity, to start with, is there's two companies, those that have been hacked and those that are going to be hacked. So don't forget how important cybersecurity is to this strategy of IoT, AI, and technology. To me, sensors are important. We talked about it. I don't want to rehash it, but optical and sound to me are going to be on the forefront, but you must still use the technology that's available today. So the sensors on the feed, right? But one important thing I want to mention that I didn't hear a lot on the sessions is you got to connect the entire supply chain. It's not enough to connect the farm. You got to connect the hatcheries, you got to connect the feed mills, and you got to connect the processing plants. Connect the entire supply chain. And then we at MTech are trying to work with new IoT components. We talked about them some, so we're trying to not only look at poultry, but we look at the farming industry to understand if we can leverage some of those IoT sensors. So data, this is some of the cleansing data that MTech can do. And maybe the last point I'll say is that feature engineering. So some of these algorithms, some of these technologies are able to build data that's not available. For example, with MTech, we can work with about 6 columns of data, and we have algorithms that create new data based on that data because it correlates it. For example, temperature, high, low, average, medium. So the computer starts building new data sets to be able to correlate. So from 6 columns, we can go to 600 columns. But again, data is critical. And to finish up, the next generation, we talked about it, guys, and everybody on the call. AI will have a major effect on sustainability, climate change, and environmental issues. It is so important to the poultry industry, and the sophisticated sensors will help with precision farming and will be more efficient and environmental friendly. Quickly, I'll just leave this. There's a link for anybody that after these sessions would like to touch with MTech, connect with MTech, and discuss a little bit about this transformation, digital transformation. We're available either through the code or through a link that we can share with the UGA team. That's my story. Quite fast.
Thank you, Simon. And I think that link is now in the chat if you didn't quite catch that from Simon's presentation. So that link is there in the chat box. Next on our panel, it's my pleasure to introduce a good friend and colleague, Dr. Doug Britton from Georgia Tech Research Institute. Doug is the program manager for the Agricultural Technology Research Program there at Georgia Tech. A lot of their program is really focused on driving innovation in advanced technologies into the poultry, agribusiness, and food processing sectors. And he really is driving that team towards very applied, actionable initiatives that have some commercialization of technology with them. So, Doug, I'm going to turn the floor to you.
Thank you, Todd, and thank you for the opportunity to come and present. I'm not going to spend too much time. I completely agree with what Simon was saying in terms of the opportunities, but also the vulnerabilities. And so I think we'll have some good conversation about that. I do manage the Agricultural Technology Research Program at Georgia Tech. And our focus there, our vision is really to transform the poultry, agribusiness, and food manufacturing sectors through advanced technology. So we partner very closely with UGA and many of the land-grant schools who have the expertise in the animal and poultry sciences in particular. And so it was exciting as I watched several of the presentations today to see all of the technologies that are being infused into these different aspects of the poultry operations. We have a couple of strategic thrust areas around biological sensing. Poultry operations of the future is kind of a push that we're looking at. And then agricultural robotics, whether that's in the live animal environment, and you heard Colin Usher's presentation earlier today, or whether that's out in the field. And so those are the areas that we're focusing on in terms of technology development. We really see the universities and industry and also our government sponsors as our partners in this operation, this opportunity to really drive activities there. So I'm going to just highlight one little quick out of the box type of idea that we've been pursuing. And this is a little bit of a cartoon. And they say there's only one time you should never think outside the box, and that's if you're a cat. And fortunately, none of us are cats, so we're going to think outside the box a little bit. And it's something that we like to do in terms of the university environment. And so this is what we call the alternative on-farm system. And early on, I challenged our team to think differently about how we might go about operating poultry systems, both at the live end as well as in the processing side. And this was one interesting concept, and I know that Brian Keeper's been involved in this up at UGA, and Jeff Buer and several others have been involved in thinking about some of these implications for poultry operations. But the idea is, what if we did some operations, the initial kill step, or maybe some of the initial stunning at the farm, and tried to reduce some of the animal welfare concerns and thought a little bit differently about how we did this. So what they did is an engineering study to start thinking about what this might look like and what might be the implications. We've also worked with the folks up at USDA ARS and looked at some of the food safety as well as meat quality questions. So the concept here is, can you build a trailer where you remove the live hang from the processing facility and start thinking about how we might do processing at the farm? And so in this particular case, in order to avoid the need for high electrical demand and or for extra chemicals, we looked at the low atmospheric processing or low atmospheric stunning system to try and do some of the operations. Again, this is conceptual, right? So what would it take? Could we load all of this onto a trailer? What would the engineering considerations be, and how would we go about managing that? And then what would be the benefits, right? So we also did some pilot studies working with UGA and the test facility up there. And then we did a number of different cases, and we looked at what would be the implication if we drove these animals after they'd been killed around for a while and then processed them, and how would that impact both the microbial aspects, the meat quality aspects, and were there really any benefits in terms of animal welfare? And rather than going into all the details on that, it's been an interesting study, right? So we found several things in terms of that it's still ongoing. And the research, I believe, is still continuing, but working with Dr. Brian Boker over at USDA ARS and others looking at meat quality, we're still trying to figure out what would be the implications of thinking about this completely differently. The benefits are you wouldn't have any DOAs, because by definition, they'd all be DOA, right? The other question is whether or not you would reduce any weight loss due to the time it takes to get the birds from the field to the processing facility. What happens with your animal welfare concerns? Because you're no longer dumping or offloading live birds and then rehanging them on shackles at the plant. You no longer have the holding facilities at the plant where you have to hold all those birds. And so is there an environmental question about that? Are you able to keep your facilities and lots a little bit cleaner? And then what are the implications just in terms of the catching, and how do things change at the farm itself? And are there ways that we could rethink some of those operations? So the idea is to stimulate thought, right? To think things differently and think about things differently. And so as we start looking at innovation, this is just a quick teaser slide that I tend to use. We like to figure out what it is. And I believe it was Clayton Christensen early on that kind of defined two types of innovation. One is the creation. Well, first of all, the definition of innovation is the creation and use of a better or more effective, and you fill in the blank. It can be material, it can be a process, it can be a technology, it can be any type of thing that you think is valuable. But the key point is it's not just the creation, but also the use. Clayton Christensen then then suggested that there's really two types of innovation. One is a sustaining innovation, which evolves with better value. So for example, Honey Nut Cheerios over regular Cheerios and all the different flavors of Tide. And then I have the iPhone X here, but it really should be the iPhone, whatever the latest one is, right? These are all incremental improvements over what has come before them. And then there's disruptive technologies. And you say, yeah, but you've got the iPhone back here in the disruptive or transformational innovation category as well. Yes, because when it first came out, this was just called the iPhone. There was no number associated with it. And it was truly transformational. It got rid of all the flip phones and all the other types of phones we were using. It changed the format and how we interacted with the device fundamentally. And so it was truly transformative. The automobile's an obvious one. Netflix is a really interesting case. This is a company that's pivoted 3 times, right? It started off as a video mailing service, and then as a video streaming service. And now it's its own digital media creation. So it creates its own content, right? So it's not relying on others. And so that's a very interesting case of 3 different pivots for the same company where they've adopted transformational or disruptive innovation. And then the digital camera. We've talked about cameras throughout the day today. But that's interesting part of the story about the digital camera is it was invented by a company who really had film as its primary business, and they simply couldn't make the transition back to the digital space, and as a result ended up going bankrupt. And so Kodak Eastman was the developer of the digital camera, and now they just simply label and license their name to other products. So it's important to recognize where you are on the innovation scale. So if on the left you have automation efficiency, and on the bottom you have time, this is a very typical technology and innovation cycle, right? And over time you get better and better and better as you climb that curve. And then at some point in time, you have a transformational innovation event. The problem is it's often in early stages much less efficient than the current state of the art. So if you were to draw a line straight up, that's your point in time, and the current technologies are much higher and much more effective. However, if you look at the new trajectory, you'll often see that at some point in time, it's going to pass or surpass the current state of the art. And it's important to be recognizing these transformational innovation opportunities and then leverage them for future growth and driving technologies forward. So I don't need to go through all of this. This is a remarkable tradition of adopting technologies. And I have to put these disclaimers in. I know I'm talking to a poultry audience, but I don't always. And so I like to make sure that people understand, right, that this has been done through a very important and valuable process of natural selecting of traits for animals. And the mortality, percentage mortality has dropped significantly. And this really is a testament to the processes of animal welfare and the importance of animal husbandry. The problem is the game continues to change, right? We don't ever stay static. And so we've got to be looking at these. And if you look at each of these trends, they're starting to flatten out, which starts to make us think that there's opportunity for disruption in that space. Because anytime you have a curve that starts to flatten out, somebody's going to come up with some ideas. And so we at the Research Institute and with partners like UGA and the industry are looking constantly to try and drive that innovation and figure out what that disruption might be. Again, I challenged our team to rethink poultry and said, what would poultry look like in 2050? And what would be the drivers? And so there are 4 key drivers that came out of this. One was food safety. The other was environmental impact. Animal welfare was a key component. And the automation and labor question was another key component. And so our goal here at the Research Institute, and I know others are pursuing this as well, is to create environments where we can really foster transformational innovation in a space. And it's really an entire community initiative, and we're excited to be part of it. How do we do that? These types of things are very important, and unfortunately we've not been able to do it in person for the last year or so, but connecting people, universities and industry and different departments in our federal and state governments, and coming up with ideas and really solving problems, both near term, but then anticipating future problems as well. Developing thought leaders, and advancing, adopting advanced technologies. We've seen that already today throughout the day, and then driving transformational innovation at the intersection of disciplines. And that's where you see we have the agricultural sciences, the technologies, and the engineering solutions. And I think there's real opportunity at those intersections. And I'll leave it there, Todd, so we can move on beyond that.
Very good. Thank you, Doug. Our third panelist is Dr. Charlie Lee, who's here at University of Georgia in the College of Engineering. Can you all hear me okay?
Yep. Yep, okay. We hear you fine. Good.
A little light's not on. That's why I'm asking.
Are you good? You good?
Okay. Hello, everybody. Can you hear me okay? Can you see my screen?
Okay. So Charlie is our director of the Phenomics and Plant Robotics Center here. So he is very much in the plant space. And I think as we go through this journey in advanced technologies and application, there's several other lessons that we can learn from other sectors and other technologies that we can adapt and utilize. So that's probably why we had Charlie on today, to talk through some of those and experiences that he's had in development in a different segment of agriculture. So go ahead, Charlie. Sorry.
Okay. Thank you very much, Dr. Applegate and Dr. Chai, for your invitation. It's quite an honor to join this distinguished panel. For full disclosure, I'm a kind of outsider of this conference. I have never worked on poultry before. I hope we didn't invite the wrong person. But for me, I really enjoyed this conference. I think it's quite a learning experience for me. I have tried to attend as many talks as possible. I have seen a lot of exciting technologies to be applied in precision poultry farming. You may wonder, why I'm involved in this. I'm interested in this precision poultry farming area, although I have worked in the past 20 plus years on plants-based precision agriculture. I think a couple of years ago, I have worked with Todd and Li Long on a AI Institute proposal. I think this precision poultry farming certainly is an important area. Recently UGA has launched a campus-wide cross-college cluster hire initiative called the Integrated Precision Agriculture. I think this cluster hire initiative includes both plant-based precision farming as well as poultry precision farming. So I think this precision poultry farming is a very important component at UGA for our integrated precision agriculture initiative. I'm involved in that cluster hiring initiative. So that's why I want to learn more about this industry and this area, and also try to be involved in the future. So here is a brief introduction of my research program. My lab has been focusing on 4 different areas. The first one is data analytics and application of AI in agriculture. In the past 20 years or so, I have been primarily focused on precision crop farming. And the second area is agricultural robotics sensing. And my lab is investigating both the ground-based and aerial sensing platforms and robotic platforms. And the third area is non-destructive characterization of food post-harvest quality using high-perspective imaging and other imaging modalities, which certainly is relevant to, for example, egg quality or chicken meat quality inspection. And the last area is kind of customized sensor development. Actually, I just realized, this is an example called the Berry Impact Recording Device Project. The acronym is called the BIRD sensor. Although it was designed for blueberry small fruit tracking, monitoring tracking, this is kind of embedded sensor, but I realized it is really relevant. The name is relevant to poultry. Yes.
Your presentation is not in display mode.
Oh, not in display mode. Okay. Let me try to resume share. Thanks for reminding. Let me see. So yep. Li Long, how is that?
It's very good now. Okay,
thanks for reminding. All right, so next I want to share some of our recent work. So this is the first phenotyping platform developed at the UGA. We call it the G-PhenoVision. As you can see, this is a high clearance tractor retrofitted with a lot of sensors, depth sensor, RGB, thermal, hyperspectral. And in this animated data, as shown here, is LiDAR data. We use this LiDAR data to monitor the growth of plants based on plot level. So this is the first kind of platform we developed. Although this high clearance tractor it works fine, we realize it is heavy, it is expensive, and it requires multiple people to operate. So recently, my group have been developing robotic systems, which is fully autonomous and low cost and low weight to reduce soil compaction for high throughput plant phenotyping. So this is the first phenotyping robot developed in my lab. This morning I saw Colin Archer's presentation. I think this robot is similar to his platform. It's based on skid steer mechanism of 4-wheel differential drive mode, and this robot can perform autonomous navigation in the field, and it has a LiDAR, Hokuyo LiDAR, which can take images, 3D images of the plants and measure plant volume and canopy height. So based on, actually what I'm showing here is on the left is a simulation in the physical environment. On the right is that kind of visualization of the 3D LiDAR data to monitor crop growth. And I think based on the evaluation, the performance was reasonably good, 6%, 4% error for plant volume and the height estimation respectively, and 0.2% navigation error compared to the overall traveling path. So for the second generation of our phenotyping robot is called the Mars Mini. Mars stands for Modular Agriculture Robotic System, because this robotic platform is kind of reconfigurable. It's not fixed. We can design a four-wheel drive, four-wheel steering, or tricycle with only one-wheel drive, one-wheel steering. As you can see from the video on the right, we test this Mars Mini in the field in terms of turning place and omnidirectional driving and traversing through these tough terrains. So one thing I want to mention is because this is a four-wheel drive, four-wheel steering mode. So basically, it can not only move forward and backward, but also laterally freely. So that means parallel parking is not a problem for this robot. So it has more flexibility in terms of maneuverability. So we also have a larger version, we call it Mars X, but I think it's more heavy and more expensive. So I think Mars Mini is more relevant to poultry industry. By the way, my group is working on commercialization of this platform. Right now, I think the Georgia Peanut Commission has contracted us to develop one for peanut phenotyping. But I think it's possible if we can make certain modifications, and this type of platform could be used for poultry house management and operation. Here I want to show you one example of using this Mars Mini for cotton seedling detection and tracking. As you can see, this Mars Mini is traversing the cotton field, and we developed a computer vision and deep learning model to detect and track and count number of seedlings to evaluate crop emergence rate. I will introduce later about this specific algorithms. But on the right hand, my lab is also investigating robotic manipulation on a mobile platform. And as you can see from this image, we are using a 6 degree of freedom robotic arm mounted on a commercially available Husky robotic platform for active sensing of cotton plants. As we have seen from multiple talks today, I think this kind of robotic manipulation could be used for mortality removal and egg removal in the poultry house, potentially. And this is the kind of computer vision deep learning framework we developed for seedling counting and tracking, but I believe it has relevance for poultry detection and tracking. So basically, we use a deep learning model called FastRCN to detect each individual seedling in individual frames, because the videos basically are a collection of individual frames. And you can see from the middle, those red bounding boxes are detected seedlings. And we used a technique called a common filter to predict the motion of those video frames. So from the first frame, we can predict this detected bounding box where it will appear in the next frame. And so in the next frame, we will have kind of two types of bounding boxes. The one is the detected new bounding boxes from the current frame. Another bounding box is from the predicted bounding box from the previous frame based on a motion estimation model. And then we can use a data association algorithm to associate these two types of bounding boxes, as shown here as a solid box and dashed line boxes. And eventually we just assign one type of tracker for each object. And then we count number of trackers, and we know number of objects in the video frames. We can avoid the repeated counting. So this could be used for chicken counting in the poultry house. And we could also modify and further develop this tracking algorithm, as we have seen earlier, to track the individual chicken legs and to score the gait and behavior of chickens. And those 4 videos basically showed the performance of our tracking and counting methods at different population densities and illumination conditions. And overall, we achieved R-square value of 0.98. The last one, I think maybe the last one project I want to show here is a segmentation of individual objects in the image, 2D images. Here we used instance segmentation. Basically, we can detect each individual instances in one image. And we measured the 3 different phenotypic traits of plants, in this case, blueberries, the number of fruit and the maturity of each fruit, and overall the cluster of the fruit, and the compactness of the fruit cluster. And those 3 phenotypic traits can be used for growers to determine whether to have mechanical harvesting, the timing of the harvesting. I believe those kind of instance segmentation methods could be used for poultry and the chicken segmentation. I guess this is the last one. My lab is also investigating 3D imaging for plant phenotypic trace measurement. Today we have seen some from some talks that 3D imaging could be quite useful to avoid 2D image occlusion ambiguity issues. So we collect those high density 3D point cloud, and we used supervoxel and machine learning methods to segment the cotton bolls and from the background, from those branches in the background. Eventually we count number of cotton bolls, and we got average accuracy about 96%. And by using other spatial sensors, we can measure the distribution, basically 3D mapping of cotton bolls. And we can also skeletonize those 3D data and get the skeleton and the architecture of cotton plants. Similarly, I think possibly we can skeletonize, maybe a chicken 3D image and just derive its moving behavior. So I think there's some potential over there. So in conclusion, I think those technologies developed for plant phenomics could be transferred for precision poultry farming. For example, robotics, I think we have heard throughout today, we can use for poultry management in the poultry house. We can also handle and manipulate certain products, such as mortality removal. And computer vision, machine learning, or in general AI technologies, I think certainly can help a lot on image classification, instance segmentation, semantic segmentation, and poultry movement behavior tracking and analysis. So I think I hope my experience and expertise could be useful for precision poultry farming. I look forward to more collaborations with researchers in this area. Thank you very much.
Thank you, Charlie. I just happen to have this off the cuff kind of comment. At some point, I want to get you in a processing facility to make sure that you have perspective as to what poultry processing is as well. So anyway, let's start. If anybody has a question for our panelists, please drop it into the chat box. If not, I'm going to kick off questions because I have a few of them myself, but I don't want to monopolize time if there's other questions. I guess my first question I'm going to put out there for Simon. Simon, since you've been involved with a number of different companies over the years, thinking about the ability to integrate across different segments of poultry production and processing, for you, what's the most exciting opportunity and return on investment for that integration across segments?
Yeah, no, that's a good one, Todd. Good question. And it's actually quite present right now. So for us, what's exciting is the partnership of the different companies in the supply chain. They're now willing to really cooperate and work as a team. So for example, I'm very busy working with the hatchery top manufacturers in the industry. So one of the biggest conglomerate now is really open to share data across one single platform. In this case is MTech. And so we all know that if we, for example, know data from these hatcheries on how that egg was set, how that chick was hatched, makes wonders for the broiler performance. And then on the processing side as well, Todd, you said it. I mean, the processing is a massive world. And there we have a massive collaboration from giants like Morel. They're wanting to partner with us and help us connect that. Think about blockchain, but for AI and for forecasting and predicting, right? Because blockchain is just an environment where people are collaborating and sharing. So just use that word as an example. But for me, it's the openness of manufacturers, but also producers, the producers, the Tysons of the world and Fieldo and Purdue and Cargill are much more open to share the data when they know that the outcome is to help performance and to help these companies be more effective and perform better in terms of as a company. That's probably the biggest game changer that I see that gets me quite excited.
Very good. The flip side of that comment and a different question. So what do you see as the biggest hurdle?
The biggest hurdle is, I still believe, to data. The problem is that, you know, all these people that talk today, wonderful, really talks, but we're sampling a very small, one of them from the University of Tennessee talked about most of this work is prototypes. They're not in the field. So we got a challenge with data, right? Because not that the companies did a bad job in the past, is that they didn't prepare the data to get into these worlds of algorithms and AI. So cleansing the data, Todd, connecting the data is the biggest hurdle by far. Actually, I think the sensors and the technology is very important, but I think at the end, we got to leverage the data to help the censoring and hardware, robotics and everything, not only from the research and development, but also then from improving it and using it. So data, number one, and number two, adopting technology platforms. So companies must start, it's what we say, you got to start small, think big, move fast. So you got to start somewhere. And sometimes I'm seeing delays on starting to adopt these technologies, waiting for that perfect moment. So the data and starting is quite important.
Question probably for Doug and Charlie both. Both of you have been, you know, in different roles, but similar, trying to advance different technologies into the commercial sector. And I realize that's probably a little different from the private sector versus academia. So the question is more, given your time frame of your careers, has that improved from the academic side? Has that changed at all? Are we doing a better job of trying to advance technologies and get them applied into the real world?
Yeah, I can take a quick stab at that and then let Charlie fill in all the gaps. But I think that there's been significant emphasis probably in the last 10 years to drive technology out of the research lab and into the commercial space. Historically, the universities would simply sit and wait for companies to come, visit, get excited about something and take a license to it. More recently, and I would say probably the last 10 to 15 years, the opposite has happened, where universities and academics have seen the opportunity, but also felt the need to try and migrate technologies into the commercial space. And so there's been a lot more activity focused on trying to do what we call technology transfer. It's still a bit of a challenge. We've also seen the model shift, whereas in the past, our program would often see companies come in and take licenses for technologies directly and then finish out the development of that technology for commercial use. More recently, we've seen companies be more interested in acquisitions. And so they're looking to acquire startups. And so we have shifted our focus more towards supporting startup activities and trying to enable graduate students and academics and faculty members to consider startup opportunities, looking at different programs that support that both in Georgia and then nationally to try and help our academics become better at doing that tech transfer activity.
Yeah, I totally agree with the Doug. I know Georgia Tech has been doing a great job in terms of technology transfer. At UGA, from my experience, I know, in the past, we developed some patent, and UGA Innovation Gateway encouraged us, in the past, perhaps waiting for some licensed companies to license. Now, they encourage us to form our own startup companies to get our technologies out of the door to our stakeholders. And most recently, I know UGA launched that innovation district, right? And in the space of integrated precision agriculture, I think there's a plan to have called the Institute of Precision Agriculture, basically to house all those potential startup companies and innovations, and to promote communication with our stakeholders.
Thank you, Charlie. Another question, and maybe from different perspectives here. One of the things I think we're wrestling with our undergrad population is really how do we make sure that the graduates coming out are somewhat data literate, aware of different technologies, realizing that our students are not engineers, but we need to make sure that they are able to interact with other folks and other skill sets. Can you all give a little bit of thoughts as to what is that next generation of employees coming out? What do they need to be thinking about as we try and build them as individuals and future leaders?
I'll give it a shot. I'll try. I'll start. Then I'll pass it to the guys. But it's good because it's happening to MTech, right? We're a technology company working with data and software mainly. That's our core. So think about it. We have that challenge as well. We acknowledge that inside MTech, and today we have over 200 people working around the world. So Todd, I think a lot of real practice, real engagement, either with technology companies or in this case, poultry operations in the data science area could be interesting to get them more data literate, right? So more connected to real world practice, either by building some partnership with software companies or even the producers, those that are very advanced right now. The other one, I think, is giving them the tools during their time in school. And in other words, there I started thinking, something like an MTech provide platforms, for example, that we could discuss that enable them to practice and work with our data in much more real world cases. So I think enabling technology in their hands, more of software products, I think it's important. But look, I think I'll leave it there saying that I said it in my presentation, data literacy is really a concern. Forget about the academic, even on the professional world. We at MTech put enormous time into it. Our data science team has grown. What we're fortunate about is we got data. We've been managing data for 30 years around the world. 97% of the United States runs MTech. So we've been fortunate to have the wealth of data to be able to use it and learn and try to understand how to build these algorithms. Of course, it's all confidential. That's the challenge again, right? We cannot share none of this data. This data is individual for every producer. But I think it's hands-on. You got to give them a lot of ability to create and to have that environment to test it, to work with it and not be so limited. So much more wide open data sets.
Dr. Charlie, any thoughts?
Okay. Yeah, so Doug, if it's okay, I will take the first shot this time and you can fill the gaps. I totally agree with Simon. I think this data literacy is so critical nowadays. I think we should not only just focus on research. I think the educational component on data literacy to educate our undergraduate students and graduate students for future employment and workplace, I think is very important. At UGA, I think we have realized the importance of data literacy. As you all know, I think Dr. Harold Sherm is coordinating and leading a agriculture data science certificate for graduate students who are majoring in, maybe poultry science or animal science and plant pathology. They can take this certificate. I think that's the first step. And most recently, I think the Vice President for Instruction at the UGA launched the AI certificate program at UGA. That's something similar to this, agriculture data science certificate, but it's broader. It applies for all different disciplines, and students can take this certificate in their respective fields. But this is still in discussion, and it has not been fully implemented yet. But I think this is a step that UGA is going to move towards too.
Yeah, I'm not sure there's a whole lot more I could add. These guys have said a good bit. I would just add one thing, and that is, you're in a unique position that most of your students are digital natives, right? So unlike you and me, who had to learn how to use an iPhone or a computer, an iPad, these students today have grown up with it, and I think it's really exciting. We watched 2 presentations from two younger faculty members. And they're very comfortable working with data and looking at it. So I think that as much as you can integrate it into the regular curriculum and make it part of the common language, the better off you're going to be.
Todd, I'll say last thing, sorry, that, for me, it's been exciting. I've been able to see growth within MTech of, some of them are actually Georgia Tech graduates, to be very precise on this one. I have to admit, and we have from UGA as well, but some of these kids, the ones that you can pick, and know nothing about poultry, yet they can understand and drive data in a way that's so exciting. So talent, right? Don't forget, talent is also life. There are some talented kids, I'll say, that come out of college and can do wonders with data. So we must follow what they did, how their journey they got to that point. But yeah, this is good stuff, man. This is what we're looking for at MTech, and we want to help both of these organizations to build a little bit more data literacy. And we're native in Atlanta, so hopefully we can collaborate in the future. But it's super important data literacy for sure.
Very good. I'm going to turn to one of the questions here in the chat box. And I think it's probably one of those questions, and I'm not sure if this is for which of you three, but it looks like a distinguishing characteristic of some of the, say, in-house robots. How can it distinguish between live and dead? A live bird and a dead bird.
So maybe I can take the first shot. Live bird and the dead bird. I think we have seen from previous talks. I think Dr. Zhao, right, from the University of Tennessee, I think he talked about thermal camera to detect live bird and dead bird in terms of body temperature. Dead bird will have a lower temperature. That's one way. I saw from this chat box, I think for tracking count live and moving birds without errors. I think what I showed in my presentation, what we have done before, is kind of opposite problem. We kind of moving the camera, but the object is stationary and still. But for animal tracking, I think it's kind of opposite. Birds are moving, but this is very similar to autonomous driving. Actually, in computer vision community, I think persons tracking using computer vision techniques is pretty common. I think those techniques I presented today could certainly also track moving birds. Although we need to, regarding the robotic platform, we need to think about whether we use like a kind of gantry system on the ceiling to monitor the large area, or we want to use moving robots such as the Mars Mini or something we have seen, and we take the relatively close proximity images to monitor those birds. I think it's possible, certainly.
Yeah, I would agree with Charlie. I mean, I think, people tracking has been an example that has been done significantly. We've done work in that space for various different groups. And we've also done bird tracking, and you saw some of the presentations earlier today using overhead cameras. Using the robotic platforms a little bit more challenging simply because you don't have a static view, you're moving as well. So you like to keep one thing fixed and the other one moving, or vice versa, as Charlie mentioned. So I think there's opportunities there. I think it can be done now. It's just a matter of whether or not it's a viable option in terms of, does it provide the value or the return on investment, right? So what does it cost to put it in, and how do you do it?
Oh yeah, there's good answers. I won't take it too long more, Todd. It's the return on investment that I would highlight for sure. That's key.
Probably a similar answer to the next question is really thoughts on how to not just get the integrators interested in new technologies, but the actual growers. So if we focus a little bit on the grower side, and how do we get them aware of different technologies, and any thoughts?
I'll surely take this one. I've been quite involved in this piece, so I'll share my real experience. I work with growers personally, and MTech does, because you got to get both into the game. You're right. You got to get the integrators and the growers. Those that can do that, those companies that can do that, they will lead this technology. Now, first of all, the ROI, there's got to be a benefit to the grower. No doubt that if the grower has to benefit, but I'll tell you what's disruptive and potentially interesting. Is if we pay growers based on these measurements, based on this data, then everybody's in the game. So if we can pay eventually in the future growers based on keeping temperature the way it needs to be set, consuming water, consuming feed, humidity, these things growers can control most of the times, right? And so as we get those KPIs as part of their benefit, I think they will embrace it and invest in it. So we have growers that want to invest on the sensors themselves. The integrators are supporting us. It's all one big family. But so big ROI, there's got to be a benefit, but also if they can be measured by this result that the data is talking. We have growers in Georgia, and Fieldo is very advanced in this, that are embracing this, and they use the data. Now, as Dr. Wicker said it at the beginning, you still got the generation, the older generation that's going to take us longer. But I think you got to get them to have a skin on the game and measure them by these data points, and that will change the game.
Yeah, I would agree with Simon. I think, you know, incentive and making it valuable for the grower to be involved. I do think there's a bit of a lag. And historically, most of the benefit and most of the technology has been driven by the integrators. I think we're starting to see younger farmers come into the space and younger generations come in, and that's that digital native concept. They want to be able to do it from their iPhone or from their tablet. And I think as we see that, we'll start to get more integration into the farms.
Yeah.
Yeah, I don't have more additions. I think Simon just in his talk, he mentioned $1 trillion potential and multiple billion-dollar potential for technologies. I think those are incentives for farmers to adopt these new technologies, perhaps. Thanks.
Yeah, right, without a doubt.
I don't know if you all had read the next one from Janice Sigford. I'm going to take a little bit of liberty with her question a little bit. You know, so as I think about, you know, the current contractual relationships between growers and integrated poultry companies, and thinking about implementation and utilization of this technology that then blurs, you know, who owns the data and how is information utilized from those contracted growers' houses. Could you all think through some of that? You know, what type of social and legal liability issues are there between that contractual relationship, and will that shift in the future? Any particular thoughts on that dynamic of that relationship?
Yeah, I'm going to wait for Simon to answer this one. But
wait a minute. No. I'm letting you go first.
But here's the deal. No, but it kind of ties into our previous question, right? Historically, these measures have not been, they just haven't been available. And so they've not been integrated into the performance metrics for growers. In terms of data ownership and management, you know, that's a very fine line. And I don't want to get into all the legalities of where that comes in. But the way the industry typically operates is there's some challenges there. Right. And there's going to have to be some recognition of how that moves forward. And we're starting to see that in some cases. And I'm not sure, I don't know all the details, but I think certain states are starting to take a little bit of a different approach, particularly out west, on data and ownership and how that goes about. I will say that I think in terms of unintended consequences, we do try to anticipate as best we can. And you saw in one of the presentations from Tennessee, you know, they were trying to look at the impact of robotics on animal welfare, right? And we had done similar studies back in 2013 where we're trying to think about what might be the implications. And we actually worked, I think, with Dr. Ritz. I can't remember who else was involved in that trial, but looking at, you know, performance metrics, right? So did the flock perform any differently, or did others perform any differently when it came to having the technology infused in there? I think the bigger question maybe is, you know, AI is not a perfect engine, and it learns. And so it's going to learn what it's taught. And so if you're teaching it with something that may have some implicit bias or other things like that, then you're going to have some of that in there. And we do our best to try and optimize or try to, the way you combat that is you have large enough data sets that are meaningful data sets that give you broad perspective, right? And so as I think Simon, you mentioned earlier, one of the problems with AI is we get lots of data points, but they're not always labeled data points, and they're not always meaningful data points. And so when you're looking at particularly neural networks and convolutional neural networks and all the new things and the technologies, and really these are not new technologies, they're just technologies that become enabled by higher computing power capabilities, right? And so we've been able to then develop them, the ubiquitousness of the Google TensorFlow libraries and the Amazon Web Services systems that they've got for doing AI. And I mean, there's a lot of available tools now. And the challenge is making sure that your data sets are meaningful and that you don't have false data in those sets.
Look, I think you nailed it. You really did. I mean, so I'll try to add something to the discussion, but and it's awesome. It's Doug, you've been around and you know the industry, and I really appreciate that from both of these organizations that UGA and Georgia Tech are so in tune with the poultry industry. I really respect that. I come from a family, so my dad was a poultry vet, so it's decades and decades of experience with chickens. A couple of things, very delicate discussion, right? And it's important to address it. And I think the industry is going through it right now and addressing it. We are a data company, so we're right on the middle of this. The best thing here is a partnership, hopefully, between the growers and the integrators. That's where it really works well, right? And you hope that stays. At the end, it's a supply chain that's vertically integrated. Yes, the grower owns the farm and the land, and the integrator owns the birds and the feed and the technical support. So there it is. It's kind of in the middle. But I think that if both can benefit and share the data, and I'm seeing it, guys, I'm seeing that happening in good organizations where the grower and the integrator are in tune with it. They're working together. At the end, it's kind of a team, right? They got to help each other to make money on both sides and to perform well in welfare. So that's the ultimate world, but I'll leave it saying it's important. It's happening right now, and it's going to change, and companies are acknowledging. That's the good news.
Yeah, I agree with what had been said. Okay.
Go ahead, Charlie.
So, yeah, I agree with what has been said. I just want to make a few additional comments. I think Doug said about this, fair AI, because recently I have been involved in this AI proposals. I think we also realize AI has biases, and we try to develop a fair AI as well as explainable AI, because a lot of things the artificial neural networks tells us it's just a black box. We don't know exactly why it makes this decision. I think for poultry industry, I think sometimes we need to understand why this kind of artificial neural networks give us such kind of results. And regarding the privacy, I think it's also very important issue. In our team, actually, one computer scientist try to develop this federated learning mechanism, so kind of distribute all those data instead of aggregate them together and have certain data security issues. So there are some ways to deal with this kind of unintended consequence of AI technologies. Thanks.
And Todd, last thing, I mean, the AI, sorry on that, because for us, and Doug's point to cleansing the data is a massive undertaking. And by the way, I cherish people to do this. I said it right, the talent. So don't get caught up that AI is going to really just control us. It's the opposite. Without us, there's no way none of these technologies work. I'm a firm believer in that. But what I say is this, I'm working hands-on with producers. So I'm a little bit more in the field, in the real world, just because of we're a business running now for many years, as Todd presented. Now, what we've done also very interesting is we've gone after models and data results that are confirming some of these top directors in the companies, which is also important for them to trust this journey. So what I'm saying is we've been lucky to run some data projects with customers using ML and RL, machine learning and reinforcement learning. And many times we first focus on something they know, they just need a confirmation that the data said, you're right, what you thought is correct. As you build that trust, then you can get into more sophisticated results that are tough to answer. So we try to go to basics first and build this trust of how the data is explaining things, and that's important.
Simon, Doug, Charlie, I think we are duly out of time. So I wanted to thank you for your participation this afternoon with this panel. And with that, I'm going to turn the floor back to Li Long.
Okay, thank you, Dr. Applegate, and all the panelists. Yeah, precision poultry farming requires a collaboration between academia, industry, and producer. I can see a lot of opportunities through this panel discussion. Okay, time to wrap up. I hope you all had a great time, and we appreciate each speaker for the knowledge and updated information regarding precision poultry farming. And we will send today's video together with a short survey, like which kind of topic you'd like to hear next year, and also which kind of topic we didn't include in this year's conference, but you'd like to hear next year. And we greatly appreciate all of your support and our department administration and extension team as well. We look forward to see you again next year, and stay healthy. Please send your question feedback to us. And also, if you have questions for our speakers, we will forward them. Thank you very much.